Yes. We just let in the last few people in, so we're going to start in 3 to 5 minutes, all right? Sorry for the inconvenience. There was to hire 10 years to be able to draw. Say some words. Invite. Oh, okay. Perfect. We're late, but there's lunch, and then there's always. We go in by the time. Let's get started in a minute, though. When did we get this bit? We went to the bathroom. Oh, okay. We wait for William. He went to the bathroom. Should I call him? Should I try to find him? How's the queue downstairs? What? The queue. A little bit, but there will always be. It's not massive, right? Good morning. Hi. 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 Thank you for showing up in such a big number. So I'm sorry for we are a bit late. There's people coming in. So we are, we wing it, right? So that's why we are. So thank you for coming. So I'll just give you a brief introduction of why we are here, because it's something very personal to me. First of all, let me thank you all the amazing people that are so crazy to believe in this. And especially to Serkan is not here because he was in Turkey to help helping with the earthquake relief, and everybody else has the UDI, so you can reach out to them anytime. So thank you so much. So why we are here? Who was in 2019? Who was at KCD Amsterdam 2019? Okay, not so many. So that's why I wanted to talk about this. So in 2019, I call it the age of innocence of Kubernetes and the world. It was in September 2019. We had so much fun. It was so great, and then we were so energized to come back in 2020. And of course, and this is where we had so much fun. Also a barbecue. This happened, right? So, and I want to recognize the fact that we lost several million people to COVID. Some people that I know as well. We lost this beautiful human. He was keynoting in 2019. Dan Ko, former president of CNCF, passed away. We keep losing people. 200,000 people lost in war. Completely avoidable deaths. So please also consider. We, as an organization, we are non-profit. So we just made a big donation to Operation Drovesti, which is a CNCF-backed fund for helping Ukraine in their efforts, but also to organize KCD Ukraine, which we all hope is going to happen soon when the war is over. So with that, that's all I have to say. And I want to invite the gold sponsor. So please also, if you have a dream, just make it happen. And thank you everybody to help me make this dream happen. So I would like to invite Mikkel from Fermion to give a little speech. We thank sponsor very much because they make this happen. So thank you.
Thank you, Alessandro, and thanks for having me here. My name is Mikkel. I represent Fermion. Fermion is a company who is pioneering the next wave of cloud computing. And Fermion has been founded by a group of people who also created the Helm project, so the Kubernetes package manager. And we firmly believe that WebAssembly is this technology that is going to power what's going to come next for cloud computing. WebAssembly is it's a technology that's been around for a while. It was built as a technology to help enhance the experience that you can get inside of a browser by allowing you to use more programming languages to build browser applications. And you might have heard of examples like Adobe and Figma using this to build incredible application experiences inside of the browser. Now today we can take WebAssembly and run it outside of the browser as well, or run it server-side as we talk about it. And if you think about what it means for an application to run inside of the browser, there are some of the characteristics of the security model, of portability, of having these applications to be very small in sizes and be able to start up very, very quickly, that we can all benefit from. Like if you think about that in the context of cloud native applications and how you run these, there's a lot of benefits that we can gain from that. So we believe that that is going to be the foundation of how cloud computing will evolve. About a year ago, we created an open source project called Spin. And Spin is an application framework for you to build serverless functions, microservices, and web applications using WebAssembly. Spin has support for 10 different programming languages. So as a developer, you can come with your existing skill set and start building WebAssembly applications by using Spin. We have some great use cases that we've done ourselves with Spin. At least we think that they are great use cases. We run all of our websites through a small CMS system we built with WebAssembly. We build fun little games, and obviously we have a bunch of Slack bots that are sitting around in our Slack channels that are also powered by Spin. Now, because of this portability that WebAssembly comes with as a technology, we don't have to think about things like operating system and platform architectures anymore. And with the ability to take a spin application and use OCI registries, like we do with containers, to distribute these, it's very easy for me to build this application once on my machine, push it to a registry, and then anyone run it in that same thing that I built on my machine, whether it's my colleague, whether it's in a Kubernetes cluster, or whether it's in the Fermion Cloud, which is a cloud offering we built for running spin applications. So there's a lot of great momentum around spin and around using WebAssembly on the server side. And we've seen Microsoft provide support for spin applications in their Kubernetes offering, AKS. There's also going to be a lightning talk during this conference by Sven. I don't know if Sven is in the room. Oh, he's right here in front. Where he built KWASM as an operator for Kubernetes to run WebAssembly workflows inside Kubernetes. And there are cases where you can use spin there as well. It's all very, very exciting. So we definitely believe that the combination of all of these things bringing together and spin as an application framework that will be available to run in many different places, that there is an evolution in cloud computing that is happening here based on WebAssembly. So if you want to learn more about WebAssembly, if you want to learn more about spin, we have a booth downstairs, and we are happy to have those conversations, answer any questions about WebAssembly and how that works. And thank you, Alessandro, and thank the whole team for organizing this event. We're looking very much forward to this, and looking very much forward to all the conversations we're going to have with you guys over the next few days. Thank you.
Good morning, everyone. How are we doing so far? Late, but it's all right. We have Jan Karoman from Enterprise DB. Please give it up for him.
I always wanted to do it. So, hello, good morning, Amsterdam. On behalf of the Kubernetes community, on behalf of the Postgres community, welcome to Amsterdam to this Kubernetes event. For me personally, this is a very special moment because I've seen this kind of convergence starting to happen. So we're representing the Kubernetes community here, which is a community-driven open source project. And the community-driven for me is an important discriminator here. On the other hand, I have the honor to present the Postgres community. Postgres, as you might or might not know, is also a community-driven open source project. So basically what we're seeing here and what we're trying to achieve is actually this convergence of all of this power. On the one hand, the development power of Kubernetes, building this kind of new age of applications, new age of things that bring value to business on the one hand, converging that with I think the most exciting data management platform there is under the sun today, which is Postgres. Postgres often thought of as this boring, old-scale, gray-beard relational database system, but it's so much more than that. We can talk about that, but then I think I will get this theater hook that pulls me off stage, so I'm not going to do that. Instead, we have Sergio Romera, colleague of mine, having a presentation on what we've done. Not me, my employer has built this thing called the Postgres operator, the cloud-native PG operator. And we first had it just as a product in our portfolio, boring because it was closed. But we've donated this to CNCF. So now also cloud-native PG, the Postgres operator, is a free and open source product for you guys to use. So if you want to know more about that, and I think you want, come visit and the talk of my colleague Sergio, but also come swing by our booth to find out what this is all about. And that's actually what I wanted to share here with you this morning. Thank you to the organizing committees. Thank you to you, everybody, for being here, because a community can only be a community if there are people. So thank you for being here in such large numbers. Thank you.
So, again, good morning. So from now on, we're officially beginning our talks with our amazing speakers. I'm honestly super excited to listen to everything that they have to say. I've read some of their proposals, and they were simply stunning and totally relevant. I would like to introduce to you Sarah Polon from HashiCorp and her talk. Hey, Sarah.
Thank you. All right, let's see if the demo gods are with me today. Yeah, but not the one I want. Let's see. There we go. Every time. There we go. Okay.
Good morning again. So I'm sorry. Could Gijs Molnar make himself known to me, please? Thank you.
All right. First of all, thank you so much for joining me this morning. I am absolutely floored by the number of people who are here to hear about the fourth industrial revolution at 9:30 in the morning. My name is Sarah. I'm the field CTO for EMEA with HashiCorp. For those of you who don't know HashiCorp, we're a community-oriented software provider. We do Terraform, Vault, and our goal is really to provide secure operations and operation provisioning across the board, regardless of what kind of environment you're in. So whether that's Kubernetes, on-prem, public cloud, or a mix thereof, our jam is really to make sure that you can get the most out of all of those things without some of the cognitive load on your developers, and making sure that that remains secure, particularly as we see the market kind of evolve in that direction. So as field CTO, one of the things that I get to do, and I think I probably have one of the coolest jobs out there, is I spend a lot of time with the Fortune 500. And with the Fortune 500, I help advise them on how to get the most out of their cloud operating models, little tweaks and things that they can do to really make sure that that operability is there. I began my career, though, as a software engineer. And once I saw that there was really quite a large disconnect between the security side of things and the velocity side of things, I put a lot of time and effort into figuring out how we can kind of start to unify those two things. Because as we see this market evolve, and as we see what's happening, just generally speaking in the world, it's no longer possible for the security people to say no, and it's no longer possible for the developers and the engineers to say, yeah, security is not our problem. So it's really about how are we unifying those two things. But before I was ever in software, before I was ever in tech, I was actually an opera singer. So I love being up on the stage. I love talking to you guys about what's going on in the world. So without further ado, we're going to get theoretical. Now, I know it's 9:30 in the morning, and I'm sorry, and some of these things are going to sound really random as I throw them at you. So it's going to sound like a bad joke, but the question is, what does a Franciscan friar, a computer scientist, two military theories have to do with scalability? I promise we'll bring it back around, but keep that in your mind. All right, so let's start with a little history before we move on. What I wasn't aware of until a couple of years ago is actually we're in the middle of the fourth industrial revolution. There have been three precedent ones, and what I made the mistake of doing was actually conflating those first two industrial revolutions. So thinking that some of this mechanization, steam power, actually was part of that assembly line and moving a little bit more into automotive and things like that. Well, it turns out these two things are very separate. First industrial revolution began late 18th century and is really about increasing the speed of goods, so textiles, things like that, and then dispersing those goods. Steam, engines, railroads, things like that. Now, with the second industrial revolution, what we saw was the late 18th century, and that lasted until about mid-19th century, and was really marked by the transition from hand production to machine production. And we see this specifically in the automotive industry. Things like Henry Ford and the assembly line, and making sure that all of these things can be a little bit more mass-produced and produced at scale. Third industrial revolution, perhaps my favorite, and probably then dates me, is about computers, technology, and again, automation within factories. So things like ENIAC, ATRAX, VHS, Nintendo, all those good things. But also then I think towards the movie Willy Wonka, and you know, the dad who's screwing the toothpaste caps, gets replaced by machinery, because the machinery is faster, it can crank that all out. So now today, we find ourselves in the middle of the fourth industrial revolution. And that's currently ongoing, and we're really towards the beginning of that fourth industrial revolution. And that's the integration of the digital and the physical with biological technologies. So all things AI, IoT, biotech, nanotech. All of these things start fuzzing that line between digital and physical and bringing that together. And as we see that happen, what's happening is that we're changing business models, we're changing adoption models. And so that's also having an impact on how we scale people, how we manage things like smart devices, because they have to be connected, but at the same time, they're tangible assets that we need to manage. Now, the last thing I want to mention about this is if you look at all of these, each one is built on the last. We can't have steam-powered assembly lines without having mechanization. Keep that in mind as we go forward. So next random topic I want to throw at you is our friend Occam and Occam's razor. So William of Occam is an English logician, also a Franciscan friar. And he says, entities should not be multiplied unnecessarily. So what does that mean? Well, basically, it's what we consider to be a practical guideline. It's not a law, it's not natural law, but it's something that we can base how we develop and how we move forward, essentially. We see it a lot happen in science and technology. And it's basically, if there are multiple explanations of a hypothesis, typically the simplest one is the correct one. So it's important that we note, though, that that's within a particular context. So if I'm operating within that context, I need to be able to make a decision based off of the fewest assumptions possible and take the fewest steps forward while I'm taking into account my environment, and that's most likely going to lead me to the best solution. Not always, but mostly. So advice that I don't take very regularly is that probably avoid overanalyzing situations. Clearly, I don't take that advice. So next up, we have the computer scientist Malcolm Conway. And Malcolm Conway first expressed this idea in a paper in 1968. Now, fun fact, this paper was actually initially rejected by the Harvard Business Review because it said he didn't prove his thesis. This is something that today, across software engineering, we hold to be relatively true, and we actually call it a law. Now, I'm sure a lot of you have heard of Conway's Law. For those of you who haven't, Conway's Law says that the architecture and design of a system will directly correlate to the communication structure within an organization. The more complex the organization is, the more that that's going to be reflected within that architecture. If I have a disparate team spread out over many locations who don't talk to each other on a regular basis and create something that's relatively complex, that's relatively true. We see that a lot. I've seen that a lot. If we have a team that's cross-functional, speaks to each other on a regular basis, has good communication, and understands the business problems, that lends itself to a simpler architecture, a simpler design, and something that's a little bit more sustainable over time. So if we distill this out, what we're actually saying is that while the underlying technology for software development is incredibly important, software development is also, it's as much of a social process as a technical one. All right, so your next theory lesson for today, Willow Run. Now, Willow Run, for those of you who don't know your American history, shocking, was actually a factory, a manufacturing complex that was located in Michigan. And it was run by the Ford Automotive Company to create bombers during World War II. So the problem was that at the end of 1939, there were approximately 1,200 bombers left, which was not enough, and this fleet had undergone immense shrinkage due to blitzkrieg, basically, so total war. Roosevelt at that time said, that's great, we have 1,200 bombers, I need 50,000 by the end of the year. Oh, and by the way, I need 50,000 the year after as well. Well, at that time, 300 bombers were being produced a year. So that's a pretty drastic increase. So 1939, which revolution? Second. What was the second revolution? Automobiles, assembly lines, Henry Ford, and the Ford industry. So they brought in Ford, and what Ford found when he came in was that there were no concise processes, that everything was kind of running ad hoc, different parts, different people making different parts, assembling things differently. And he said they were producing a custom-made plane together as a tailor would cut a suit of clothes. No two were alike. So then what Ford did was he came in, he overhauled the entire system. It wasn't perfect at first. There were still some major issues, but it was an iterative process. And basically, by using common reusable parts, specialist functions, assembly lines, you see where I'm going here? The plant was able to reduce the speed of creation of a bomber to 63 minutes. That's down from 1,752 minutes for a single bomber earlier in the year. So suffice to say, 5 years later, there were more than sufficient bombers, and this has really become representative of what is possible with automation, with industrialization across the board. Last military concept of the day, the OODA loop. So the OODA loop is a concept that was created by, his first name, forget it. Anyway, Colonel Boyd. And Colonel Boyd came up with this idea that in order to train a pilot and to have them make the best decision, they need to have this loop in place. So it stands for observe, orient, decide, and act. It's a 4-step process, and it's something that really guides particularly air combat pilots. And the reason that Boyd came up with this was when he was in the Korean War, he noticed that the best pilots weren't the ones that had the best technology. They weren't the ones who had the best machinery. They were the ones who could create this loop and execute on this loop the fastest. So as a result, what they did is they started training the Air Force. And they started training the Air Force to observe, orient, decide, and act. Because what we've seen is that in competitive situations, the faster you can complete this loop, if you can complete it faster than your competitor, you actually have a higher rate of success. So now, it's still used in military, it's still used in military strategy. It's also something that we've actually adopted into the business world, particularly in highly competitive situations. And I think this is something that we see particularly with the large CSPs, for example. They're constantly competing against each other, iterating, coming up with different services, products, so that they can be first on the market, so that they can have the larger market segment. All right, but we're here to talk cloud native. It's now 9:45 in the morning. So why am I standing here talking to you about seemingly random concepts and history? Promise, it all ties into each other. So let's talk a little bit about IT. Now, when I work with different leaders in the industry, what I really see is that we have 3 common goals. And within these 3 common goals and these strategies, some are more successful than others, if I'm going to be really honest. We see all ends of the spectrum. We have certain companies that are very on top of it, leading cutting-edge technology, and fulfill all 3 of these. We have others who are really still trying to orient and figure out how do we approach these different things. So the first one is really about accelerating that time to market. How do we get there faster? And how can we make sure that we provide that ability to do CI/CD consistently across the board so that our app devs are releasing business logic and being able to really augment our position as a company and our deliverables. Now, one thing to keep in mind, this becomes incredibly important during a time when we have an economic retraction. Because what has been our bread and butter up until now, if we look currently, say we have a 10% inflation, basically everything just got 10% more expensive. But we're not making more money based off of it. So what we need to take into account then is that we really need to innovate at that point, because we can't rely on what's currently in place to maintain that structure. So that time to market becomes really important, particularly during a recession. Then we have security and governance. I think none of us are probably shocked to hear this, particularly as we see more attacks. We see, it's in the news, large companies, everyone's getting hit. It is a reality. You have an attacker on your network. So then it becomes a question of how do we enable security teams to set policy and set policy as code so that the rest of the organization can run within those confines, within those guidelines, and make sure that they still have that time to market. And then last but certainly not least is about improved operational efficiency. By improving your operational efficiency, you maintain that consistency, and the other 2 then can do what they need to do. You have the security, you have the time to market. So all of that rests a little bit on your operational efficiency. So let's go back to Occam's razor. GCP. They list 100 different services and products in their service catalog. Azure says over 200. AWS says 238. So I'm a mom. I have 2 girls. They're 9 and 11. If I give them 5 choices, it's already chaos. If I give them 238 choices, I promise you all of us are going to be in tears. They're going to be in tears, I'm going to be in tears. I'm going to guess the dog's going to be in tears, because they're going to want to choose what's shiny. They're going to want to choose what tastes good. They're going to want to choose what they think is logical in their context, but that's not what's logical in my context. I don't want to have to clean up somebody, because they have a stomach ache or they didn't make the right choice. Because in the broader context, which is where I'm coming from as the parent, we don't see it the same way. So if we want to translate that to the IT world, how are we enabling developers, making that simple for them to make the right choices so that they can support the business value? And by supporting that business value and making that more simple, we're providing more room for innovation. But room for innovation that's going to mean something, that's going to hold value down the road. Now, if we're talking simplicity, let's also talk about Conway's Law. Because you know what? These two things actually tie together. I need things to be simple on the tooling side of things. I also want things to be more simple on the people side of things. I have a colleague. We affectionately call him Aquaman, because he looks like Aquaman. And one of the things he always asks his customers is, if you had one wish to change your organization, technical, people, anything, what would that be? Now for me, without a doubt, without a question, it would be to solve the people problem. Because that is the most complex problem that exists out there. Now, if we put in Conway's Law in place, what we're seeing is that, it becomes a strategic and an executive decision. So how can we create some of these multifunctional teams? What we know, anthropologically speaking, is that humans are capable within any particular context of about 100 relationships. If I look at some of these organizations, which are hundreds of thousands of people, we need to figure out how we can boil that down so that we have the correct relationships and these cross-functional conversations, because we also know that cross-functional teams are higher performing teams. And that also reduces that complexity in terms of people, which means your organization is going to become simpler. Willow Run. I'm just going to say it. You can't scale a unicorn. You can't make a unicorn on an assembly line. So why are we trying? It seems silly to put the fate of an organization in the hands of a couple people who are creating bespoke tooling when we know that the current attrition rate is 23%, and we know that there are more jobs on the market than there are people to fill them. Make it a conveyor belt. Make it possible so that when that person leaves, your business isn't left high and dry, and you aren't including more security risk, velocity risk, complexity risk. And again, if you do this, that gives your unicorns the opportunity to innovate and do that in a way that is then consumable for the entire organization. OODA loop speaks for itself. If I'm focused on the outcome, if I'm focused on complexity, getting through these political conversations with all of these different people in all of these different places, because Conway's Law says that, that determines my architecture, this is what I end up with. I end up with spaghetti. I don't want spaghetti. I want something clean. I want an iterative loop. I want to be able to improve my architecture. I want to be able to improve my development. I want to be able to improve my organization. But if I don't have that feedback loop, if I don't have the velocity of that feedback loop, I can't have that iteration. I can't have that feedback, and it makes it a lot harder to drive that innovation as a result. So, mostly engineers in this room, I'll step back from theory and give you some numbers. 76% of organizations are multi-cloud. That's just cloud. We're not talking platforms, we're not talking VMs, we're not talking flavors of Kubernetes. Cloud. That in and of itself is an incredible level of complexity, especially if you're looking at those 3 pillars. 75% of cloud migrations are over budget. Now, if we're looking at 80% of organizations in the world moving to cloud and 75% are over budget, and we're looking at 10% inflation, that gets really expensive really fast. 45%, so almost half of that budget is actually going to change management. Now, I would be willing to say, if all of you go back and you look at your change management and the things surrounding that change management, most of that change management can actually probably be automated, industrialized, simplified, and you will unleash a lot of that budget in terms of that 45%. And if we look at revenue loss just based off of misconfiguration because people are doing bespoke things within organizations and not following best practices, if we just look in the case of networks, just networks, 9% of revenue lost. That is an insane amount of money. So I'm going to bring you back to this. Time to market, security and governance, operational efficiency. How do we embrace and support these priorities to bring efficiency to the industry? For those of you who know HashiCorp, this isn't going to be any surprise to you. Well, when we start across the board, what we almost see is this tactical cloud experience. Within the tactical cloud experience, we just unleash developers, engineers loose in AWS, say, do what you need to do, develop your thing, go to market. What we soon understand is that there's no repeatability. We don't know who's running what the ecosystem looks like. Security people aren't happy because everything is bespoke. They can't come up with anything to follow everything. It's not scalable. Operations people, very similar. They're saying, yeah, I can't follow all of this. This is all different. How do I use this within my organization? And networking people, they're all like, yeah, I'm supposed to do all of this by hand. This is all different. I can't manage it. How do I do this? So it's not sustainable. It's chaotic. There's no feedback loop. And it doesn't work. So then the next step, and once we realize that we really need to get it together, create something a little bit more packaged and consistent, is to create that cloud platform team. And really the goal here is to create that underlying functional team that can then support the rest of the team. So that when you have your application and development teams, you have an embedding of somebody from that cloud team to help you make that connection. That simplifies the communication between everyone, and it makes sure that knowledge is being passed seamlessly from one team to another. So basically, if we embrace that in our specific context, using the most cutting-edge, coolest technology, is it the right choice? Probably not. The boring thing to say, sorry. But it's the way that we can scale. It's the way that we can innovate or create time so that later that we can innovate. So basically what we're doing is simplifying the ecosystem and creating a broader cross-functional platform. And that is going to allow us to collaborate and automate, drive out some of those unicorns, and really just help us migrate that digital and physical so that they're kind of more unified. Now, once we've done that with public cloud and what we're used to, then the sky's the limit. We can start doing this with whatever we want to, because we know it scales, we know it works, we know it starts driving out some of these bottlenecks as well, and you have that collaboration, that iterative loop. The simplicity is there, the collaboration is there. It works. So, bringing this back. We talked about Conway's Law. We talked about Occam's Razor. We talked about Willow Run. We talked about the OODA loop. All of these things boil down into simplicity, communication, standardization, automation, and agility. I know it's easier said than done, but as you go through your development practice, as you as teams, platform teams, app dev teams, start looking at your best practices, what you're doing, what your day-to-day looks like, start thinking about how these things are playing into that development process. How are you simplifying things, making sure that it's easy to pick it up, that things work logically? Simplest answer is usually the correct answer, remember? How are your teams communicating? Do you have an open line of communication with your platform team, with your app dev team, with your SRE team? How does that work cross-functionally? Because again, high-performing teams are teams that communicate and the trust is there. Standardization, how do you make sure that you have that cookie cutter? We saw with Willow Run, that's an immense gain. 63 hours down from 1,752. Imagine what you can do if you kind of take some of that time out of your development process. Then you can really start to innovate. Then you can really start playing with the cool stuff. And then, once you automate that, have it go down that assembly line, wow. Then you know, the sky's the limit. Then you start playing with the fun things, and you get the candy. And then making sure that agility is there. That feedback loop is critical. One thing that McKinsey says is there's a direct correlation between the speed of iteration and the performance of a team. So the faster the iteration, the higher performing the team. So I'll leave you with those today. Thank you so much for joining me, and I look forward to seeing you again.
Now, thank you very much, Sarah. That was fantastic. And just for the records, I do love some spaghetti. So it was great to get theoretical with Sarah. I would like to let you know, guys, we are running off schedule. Three in the organizations are Italian, and so we have Italian times. We were supposed to have a 15 minutes break to get from downstairs. Who wants to go downstairs and wants to stay upstairs? We have a talk happening at 10:10 in downstairs, and we are going to have other 8 minutes, an 8 minutes break, and then we are going to speak with the guys about gRPC. Thank you.
Okay, cool.
Good morning, everyone. We are going to start. We're going to give it up for Gijs Molnar from Spotify with gRPC. I would like to have Marcel Klaassen, if here. Can he make himself known to me, please? Thank you.
Perfect, thank you. Gijs, yeah. Gijs. Perfect, yeah, thank you for having me. 10, 12, it's early. I'm fresh, you're fresh, so that's good. And I'm going to talk about proxyless service mesh. But I'm going to specifically talk about migrations. So I'm Gijs, I'm Dutch, if that's not obvious. I work for about 10 months at Spotify as a system engineer, and I'm also, since the beginning of this year, tech lead of the Hermes deprecation. I'm going to talk a bit more about what is Hermes and all the pain points we have with this deprecation project. Before, I was a research engineer, also a contractor, and I work mostly in science, specifically in astronomy. And I've been a lot in South Africa. I worked in radio astronomy there. And in South Africa, they've been building a huge radio telescope called the Square Kilometre Array. I was specifically doing research in large-scale data reduction pipelines, containerized data reduction pipelines. So I did a PhD in that. If that's a good idea to build these pipelines that way is a different question, but that's why it's research, right? So many talks have some quote from a person in it. I thought it was a good idea to have one also. And I'm quoting Warren Buffett. And I'm quoting him as, it's good to learn from your mistakes, but it's better to learn from other people's mistakes. So I'm this tech lead migration now, so I was looking around at migrations that didn't go flawlessly or didn't go very smooth. And in science, there's many, but I don't want to bore you with some obscure radio astronomy package that we try to migrate away. So I want to focus a bit on Python. And the migration for, I don't know if everybody here is old enough to remember that. I think so, if I look around. But the migration from Python 2 to Python 3 didn't go very well. It took way longer than Guido van Rossum, who's also Dutch, anticipated. So then, to quote Guido van Rossum, I had no idea it would be so hard or take so long. I still think it was the right thing to do, but it's clear I underestimated the magnitude of the task. Poor Guido. So why do people want to migrate? So often, if you migrate to something, you migrate to something that has improved features or new features you want to use. It could be that there's better support, paid support, or there's a community with people that you can ask questions about this new thing that you're using. It could be compatibility, that this new thing that you're using is way more compatible with all these other things that are also new now. Your community could be larger, again, that you just have more people that you can ask questions to, but also you can hire people easier. So if you have new people coming into your company, you don't need to explain all this old, obscure technology to them. They already know this technology and they can start quicker. But there's also a national resistance within every company that has an older stack. It could be that your software is very complex and it's very hard to adjust. And that's very much the case in radio astronomy, where you have these very old packages from the 70s written in Fortran, and you need to modify that. And there's not very many people that can do that. It could also be that you have a lack of resources in money or in humans or in time. That is just not a priority now to migrate. And we see that a lot within Spotify, where we know it's important, but it's just there's a lot of other important things happening. So this migration doesn't float to the top. And it could also be that a lot of people just think it's good as it is now. You don't need to change because it just works. So if you put this in a plot, then, and you have this technology as the latest and greatest, and we put this on the right, then you have all these cool new features, but it's very hard to migrate because it requires a lot of changes. And I would argue Python 3 was somewhere there. And on the left, there is technology that is actually might be easier to migrate to, but it has similar features, and it's just not that interesting to migrate to, and there's no need to migrate to because we're already sort of there. So you want to be somewhere in the middle there. Sorry. So now I move a bit back to Spotify. So Spotify was the first paid streaming platform. And they were pioneering in this field in that sense. And they were one of the first that solved this problem, or they were the first that solved that problem. And they needed tools that didn't exist yet. So I had to make these tools. With that comes great creative freedom, right? You can do what, you can make this because there's nothing there yet. And very smart engineers before us working there made all kind of very cool things in encryption, in online streaming, compression, and it was all very much state-of-the-art technology, what they've built. And the tradition within the company was always to adopt the latest theoretical things available to us and utilize that to its full potential. And it's the same with the microservice architecture. Like, as soon as Docker was invented or became popular, Spotify was one of the first to actually go full on this kind of technology. So there's a lot of these old technologies that we invented, and I'm not going to mention all of them, but there's three that I want to zoom into because they have a close relationship with containerized platforms. And they are Hermes, Helios, and Nameless. So Hermes is a protocol invented by Spotify a long time ago, and it behaves a bit like HTTP, but HTTP was just not good enough. And HTTP 2 didn't exist yet. HTTP 2 solves many of the problems that Spotify saw with HTTP for back-end to back-end communication. So it's home-built, built on ZeroMQ, and Protobuf. Protobuf back then was also just released by Google version 2. And it supports bundling multiple requests in out of order. So this gives way less overhead and gives better performance and saves money and data usage. Another technology we made ourselves is called Nameless, and this is a service discovery service. And it's based on DNS server records. And DNS service records are not that popular, but they're very similar to CNAME records, that they create a list of host names if you resolve a service, but also include a port number. So all internal Spotify services register per region with a Nameless instance, and then other services can query this Nameless service to get all the hosts that offer a specific service. And then we utilize client-based load balancing. So the client decides which service is going to be picked, which is usually round robin. Nameless operates per region, so we have multiple regions around the world. And, but if some services for some reason don't run in a specific region, then we can manually redirect traffic from one region to the other. But this is a manual task, semi-manual. It's also important to note that Nameless works across different environments. And that, I mean, it works with classic VMs and Kubernetes hosted at Google or at AWS. It's completely independent because it's DNS. And the third one is Helios, which is our own homebrew container platform. And we're very proud to mention that, and we actually recently discovered this, that a colleague of mine did some archaeology in programs of Docker conferences, and we discovered that Helios was actually announced one day before Kubernetes was. And back then, functionally, they were very similar. They are a platform where you can schedule containers, you can schedule them together, and you can expose them on a network, and you have an API. But quickly, Kubernetes just became way more popular and took over. So, but up to today, Helios is still used, but we're migrating away from it. So, but these technologies brought us where we are now. We have a worldwide company leading the streaming business, and we're everywhere. But still, all these technology just cannot keep up with the growth we're seeing. Another problem is that all these things come with overhead, right? So you're the first mover, you create something, you make it, but then you have other people learning from your mistakes. So they create something that is better, and other people start using it that has more momentum, and before you know, you have your own do-it-yourself technical debt. Also, the company grows. It keeps on growing, and all the technology that we've built ourselves only goes so far and keep on adjusting so it can keep up with the scale. Many of the tools that we created doesn't have proper third-party support. For example, the protocol. There's no package sniffers that understand, that offer great support for something like Hermes. And many new developers, including myself, are just not familiar. Like I joined Spotify 10 months ago, and I have to learn a lot of these things and reverse engineer my understanding of something like Helios. So I want to move away from Helios. And I already explained it. Kubernetes has way more momentum, and Kubernetes is all around us, and all these big cloud providers just offer this as a service. So this is a sort of solved problem. Hermes is also Spotify only, bad third-party support, but most importantly, it lacks proper support for load balancing techniques, and it is not zone aware, or it was not. I'll explain a bit more about that. And also Nameless just doesn't scale. It's hard to add new features, mostly because the response size of a Nameless response package is limited to 64 kilobytes, which is absolutely tiny in these days. So what this means is that if you use Nameless and you want to use, for example, the Spotify playlist API or something, and you want to discover this service, you get back one response of all the services, all the host names that represent this service in a region. But that whole list can only be 64 kilobytes in size. In practice, that means that we can return about 800-900 host names, but only those host names. And you cannot add additional information, or you need to reduce the number of hosts. And it will become a problem if you have so many hosts. So we're really pushing the limits of DNS there. And there are just better technologies available now. Another problem with DNS is that it's actually quite slow. There is a lot of caching happening, which is unknown where the caching happened. You can play with that, with changing with your time to lives and things like that. But that it's just very hard to debug your problem. Another problem we have is the cross-zone traffic problem. So if you go to your favorite cloud provider and you create a new Kubernetes cluster, they advise you to just have 3 zones and fire up some VMs in those zones, and don't really worry about that. And just randomly deploy your pods over it. And there is some cost involved for inter-zone traffic, which is about like 1 cent per gigabyte. And which all sounds fine, but this becomes really a problem if you don't think about that and you start to transfer petabytes or exabytes of traffic between your zones. And suddenly, this becomes really expensive. So we sort of made the mistake by growing and not really thinking about that, and planning to migrate, but then the migration took longer, and before you know, this becomes really expensive. So we want to save money also, and we need zone-aware routing. So this was hard to do with Nameless. But then I had a colleague who was very smart, and he hacked Hermes to hack in zone-aware routing, and we're actually deploying this as we speak, and we're saving money as we speak. We merged a couple of pull requests yesterday. But we cannot keep on doing this. We cannot keep on hacking these protocols. While there is more robust, future-proof technologies available. So now to service mesh. So for people who don't know what is service mesh is a different way you can manage traffic going through your cluster, where traditionally you have your Kubernetes clusters and you have your pods, and if one service you want to communicate with another service, they could just do that. You say, okay, it has a name you can resolve, and then maybe there's a couple of pods. Service mesh introduces another abstraction layer in this whole contraption, where it has a dedicated infrastructure layer, typically manifested in the form of a proxy. So in practice, this is almost always Envoy. And this proxy downloads or communicates with the central configuration entity called the control plane, traffic director in this picture. And this traffic director or control plane configures the proxy. And what this means is that the client can then be configured to pick specific clients in a specific zone or in a specific cluster or region, and this way you have way more control over your traffic routing. Like you can do zone-aware load balancing, things like that, and fallovers to different regions, and even also if certain zones get very expensive, you can play a bit with the metrics and redirect traffic to certain zones or areas or regions. So traditionally, a service mesh has been realized with a proxy, but the dream is the proxyless service mesh. And that's where we're heading to. So what you can do, you can just get rid of this proxy. But to do this, you need a client library that is able to communicate with a control plane. Now, luckily, all the modern gRPC libraries basically have support for this. So now it's just a matter for us to start switching to gRPC fully. So Traffic Directory is the managed service for Service Mesh by Google, in case that you didn't know that. An alternative is Istio. I hope I pronounced it right. I always get a bit confused there. And so you might ask, why don't we use that? So the problem with Istio is that it has multi-cluster support, so we have many clusters per region, but we need better support for that. More advanced routing techniques that Traffic Director actually has support for. Also, we have global routing, so we need certain services are really, for legal reasons, for example, bound to certain regions, and traffic needs to be redirected in between. And also, we're still not fully converted yet. We still have significant infrastructure running on Helios. So why would you want to go proxyless? Well, you just have less moving parts, right? You don't have your proxy, you don't have this mental overhead, and we actually already do this. We already do, as I mentioned before, we do this client-side load balancing, where we have our Hermes client that gets these nameless records in and decides who to talk to. It's a bit stupid. This way, we can make it a bit smarter. So this whole architecture is philosophically compatible with what we've already been doing, and everybody is reasonably comfortable with it. So what is stopping us in this whole story? So the Hermes gRPC migration is something we are slightly underestimating. It's actually quite hard to migrate a protocol. I mean, I've not been involved with the Helios deprecation effort, but that seems way more easy, where you just have a container, you move it to a different platform. While here, you need to modify the content of the container and also the protocol that the containers talk in between. And so there's reasonable resistance within the company, natural. It's not that people don't want to, but it takes time and effort to move and help all these teams and all these services to integrate a new protocol in their infrastructure. Another problem is that we need to regain trust again after a massive incident. And the massive incident I'm talking about, it gave us the honor to be the top one incident at Down Detector last year. So in March 2022, we had a global incident, and Google accidentally pushed the faulty configuration to Traffic Director, which was propagated to the whole infrastructure. In combination with that, there was a bug in a library that we used that propagated that error even further. The result was that basically every service within Spotify started returning 404, and as a security measure, all the clients were logged out. So we have like a perimeter security check, and people start accessing things that they're not allowed to, they get logged out. So I don't know if you ever realized, but one of the things with Spotify is that you're never logged out. Nobody ever needs to re-log in or type their password. So the problem is that nobody knows their password. So this problem propagated to all the company. Like suddenly you have all these clients, but also artists who are like worried about their income, like contacting, resetting passwords, contacting support. For weeks, this was shockwaves going through the company. So the rollout to Traffic Director. So, I mean, there were only very few services migrated back then, but some very important services were migrated as a trial project. So that rollout got rolled back. So now afterwards, we sat down with Google and we said, like, look, we really like Traffic Director. We want to use it again, but we need to prevent it happening there. So Google sat down and looked at what happened, and they came up with a couple of solutions to to address these issues. And one of that is just make it harder to make this mistake, not to push a faulty configuration or break the configuration. Another thing is that they introduced canary rollout in regions, and they improve the observability of what's happening. So you have early detection of if anything is going wrong. So to bring everything together, to adopt service mesh, we need gRPC. gRPC is a big pickle. We should not underestimate the migration. And just asking people internally, it doesn't work. Spotify is a community of people, and just asking nicely, it doesn't help. You need to create a bit of an incentive. So that's what I'm working on now. I'm not expecting miracles, but I just want to make it the obvious next way. And we're working on that with certain teams. So we're slowly migrating very important services and hoping that has a sort of network effect within the company. So, but I have faith we will get there. So that brings me back to the quote that I showed from Guido von Rossum. So actually, that's a fake quote. It has been created by ChatGPT. He didn't say that, but he could have said that. so anyway, that was my talk. So thank you. I am open for questions, but I'm not sure if I can answer all of them. That's. You want to point, or should I point, or how do we do this?
Does anyone? Thank you very much, Gijs. That
yes.
was amazing, and I really thought that Guido said that.
There we go. Yeah, I fooled you.
Does anyone have questions for Gijs? Yes. Can you keep me on?
Hey Gijs, thanks for the talk. Back in the days, before Service Mesh existed, Netflix had a library called Hystrix. And they moved away with it because it was forcing them to do everything in Java and use that library and cause tight coupling. Now you're moving in exactly the same direction. What has changed?
Sorry, can you repeat the one thing?
Back in the days, Netflix was using Hystrix as a library to do the communication between the services and service discovery. And all of the things that a service mesh does nowadays.
Yeah.
And they moved away from it because they didn't like that all of their microservices had to be programmed in Java and had a tight coupling with that one library.
Right, yeah. gRPC is a protocol with implementations in almost all languages. So we're not tightly coupled to Java. And I mean, we're investigating other languages also. We're fully Java-based now, with some Python here and there. But the beauty with gRPC is that you can write these protobuf definitions, and you can generate code in almost every language. So we are language agnostic there.
That's the important difference. Thank you.
Any more questions for Gijs? No? Well, thank you very much, Gijs, then. Give it up for Gijs, please.
Thank you.
So we were this morning 15 minutes late with everything. Then we switched into being 10 minutes late with everything. Then Gijs now just brought us 5 minutes. So we are in a regression state that is fantastic. Eventually we're going to get on time to be
Dutch
late again
efficiency.
later on. We are going to have a little break now and start again at 10 past 11. So it's 10 minutes after the schedule. We are going to have security talks with Marcel Classen, and I would like to have Marcel Classen make himself known to me, please, if possible. Well, I'll see you all later on. Thank you very much. Good morning again, everyone. We are charmingly early. We have still 10 minutes to go. If you still want to go to the toilet, grab a coffee, grab some water, something to drink, a little breather, you can. We are going to start at 10 past 11 sharp with sysdig and finding runtime, detecting runtime, well, threats. That's me again. So we have got voice that we can start a little bit earlier so that our break will last its normal time. We're going with Marcel Klaassen, Enterprise Sales Engineer from SysDig. Please give it up for Marcel.
Thank you. Good morning, everyone. Ooh, a lot of noise. Today I would like to discuss with you a little bit why we do need runtime threat detection in your Kubernetes environment or container environment, and how we can do that with Falco, the open source software that we are using. So first a little bit about myself. So as William already said, Marcel Klaassen, I'm a sales engineer at SysDig. Meanwhile, I also keep myself busy with other things like some energy monitoring equipment and containerizing that in my K3S cluster that I have at home at multiple locations, because my wife has an office somewhere else, so I misuse that location to put the cluster, of course. Some pumping equipment for my pool, because I hate doing it all myself, so why not automate it? And of course some security monitoring, and as you see there, this morning I left my home, and with a 80% certainty it was me as a person leaving here. But that's not what I'm here for, so basically let's take a look at the agenda. So why do we need runtime security? That's the first thing that we would like to discuss. After that, let's go for introducing Falco. So what is Falco? What can we do with that? I will tell you a little bit about the Falco rule engine, and then I will explain about how we can expand Falco with other plugins or sources and output information. So why runtime security? So let's take a look at this departure hall of an airport, right? So we have a lot of people going in and a lot of information that needs to be processed by us. So what do we need? What do we see? Are we interested in what's happening there? Do we want to keep things safe here? And that's the main reason that we have security at an airport, right? We want to make sure everything is secure. But what do we do with all those signals? Because we have a lot of signals here. We have people scratching their head. I don't care. We have people smiling. Do we really care about smiling? No, we don't. Then other signals like, is this guy armed? No, that's a false positive, right? We don't want false positive of all our signals. We only want to make sure that signals are correct. So for this guy, for instance, that's an armed guy. So this is a threat for our system, and we want to make sure that this one is detected. So at the departure hall or in the security center in the airport, that's all arranged for us. We lead people into the security lanes, and they are tracked, everyone, one by one. But how are you going to do that in your Kubernetes environment or your container environment? So why do we need runtime security? Of course, to detect malicious behavior. And I know all of you probably are certain that you build your images with all the pipeline, vulnerability scanning, everything is out of it, no critical vulnerabilities left, everything what is fixed can be fixed. We know all about it, but then still, right? You are running in a deployment, and what happened in a deployment, if you spawn a container of your image, the image is running, right? So we can get some drift. Is your application really doing what it should do? Is there a misconfigured application in there that is allowing an adversary to get into your system using a malformed PHP script? And what about zero-day exploits or unknown exploits, right? So you want to know what's happening inside your environment. Next to that, all the images that you run in your environment are not always yours. So you also are depending on third parties, and you don't know what they built, what they've done. So you want to know what's running inside your environment. After that, if you've detected a threat, you want to know what's going on, but you also want to be alerted upon that. So right away, preferably right away when it's happening, so not 1 hour later or a day later, sometimes you see that, or at a report 2 days later that you see, oh, there was a threat. It's too late. You want to see it now. Now it's happening. Now you want to see the alert. Next to that, after the threat has been raised, you want to do some forensics, check audit activity, get some knowledge about what happened to see if you can prevent it from a future use. And the last one, not the least important is you need to be compliant with a lot of security frameworks. If your information, if your environment is not correctly configured, you are not compliant. If you have certain files that can be written to, you are not compliant. So with Falco, you can detect what's happening on that. If we take a look at the runtime security, we all have that applications that are running, and all the applications are spawning their details to the screen. So you all recognize the output of all the different applications that you have, but none of them are confirming to a single source of truth. So they only send out the information that they're programmed to do so. So if there is a malicious activity in that application that is not known as a malicious activity in that certain application, they don't recognize it. They just show the output as it is. Someone is getting a PHP file, but you don't know what's wrong or what's right. So how are you going to get around with all those events from all the different sources? This might not be the right reason, right? It's probably a good start, but it won't help you. This is the time to introduce Falco. So Falco is a cloud-native computing foundation object. It's incubating, actually. And you can consider that as your security camera for your containers and cloud. So basically, Falco is taking a look at everything that's happening in your system on your container level, but also on cloud and other sources. First of all, where did Falco come from? From the people that are long around in business here, maybe they know about Etherreal, right? So Etherreal, the predecessor of Wireshark, that was something around 2000 when I was still young. And at some point, somewhere around 2005, I think, or something, Wireshark was created, and it was basically due to a naming discussion with the owner of Etherreal. And one of the creators of Wireshark, or the co-developers of Wireshark, started a new company named Sysdig. And Sysdig created a deep container, as it's called, container forensics troubleshooting tool, basically based on Wireshark, but then specifically for containers. Out of that, Falco was created. And Falco basically was created because he had that static information about container information, about syscalls being done and all the kind of things, but he wanted to have information what was happening real time. So Falco is, as they call it, right, cloud-native threat and anomaly detection tool. Currently, Falco is now incubation project in the GitHub. We have over 7K GitHub stars. I need to check it because every time it's changing, of course. Not live counters, by the way. And over 50 million downloads. And we have a lot of contributors in that space because it's an open source community, right? But you see the names there. This is only a very few of them that are contributing to Falco to being a real-time threat detection engine for your cloud and Kubernetes environment. A little bit in repetition, but Falco is the open source for real-time detection of threats, anomaly detection, etc. So how does that function? This is a very high-level overview. Basically, Falco, or the creators of Falco, think there is only one source of truth in your system, and that's the syscalls. So we can depend on all kind of information, like logging information from NGX, or whatever application that you're running, but they miss certain information. So Falco is using all the system calls, they are processing that system calls and providing you alerting output. So what kind of problems is Falco solving for you? So our host, our containers, something doing that they don't. Are the processes being spawned? Is something changing in your environment? Are config maps or something like that in your Kubernetes environment being called? Are Kubernetes API calls being called that are not able to be called or shouldn't be called? Are users legitimate or not spawning a shell inside a container? That can be done via the kube control commands, or it can also be done, for instance, from a malicious PHP file, right? Or anything like that. So that's the kind of information that you can, on a high level, get out of Falco, and that's only based on the Kubernetes environment. In the later stage, I will tell you also about plugins which will provide you the option to get additional sources into Falco. So if you talk about what this Falco is running, so basically this is an overview of what the architecture is of Falco. Falco will be installed on your system using a kernel probe or an eBPF module of using eBPF if you don't like any kernel probes. From that point on, it's taking all the events in your system, like host and metrics, data, problem sets, but specifically for us, important security events. It doesn't matter what runtime you're using, if you're using Docker, Containerd, or CRI-O, or anything like that, we will see all the information on that specific node. You can install Falco using a single application on a host, which for a cluster is probably also more easy to install it as a daemon set. And we provide options there for installing it as a daemon set, so your complete cluster is directly protected when installing it. So what do we need to think about when output is being generated? So the initial Falco representation, the default Falco installation is basically only giving you information on an output basis like this, right? So fire syslog, like notice a shell was spawned in a container with an attached terminal. Warning, netcat runs in a container that allows remote code execution. So basically this is the default set of Falco. In a later stage I will tell you also about plugins that will give you the possibility to get extended data information and also correlation with other clusters together, because basically the negative part between quotes of Falco is that this standard installation of Falco is running on a single cluster. So if you have multiple clusters, you need to go to multiple instances and get multiple data sources to collect the data. So let's take a look. Let me see if that works, because I had some issues with the screen. Let's do it like this for a moment. Okay, see if I still have connectivity. Oh, all good. So what I have just a simple installation here, a Unix terminal. Hopefully it's readable. And what I have here is basically an installation where I installed Falco on Linux. Nothing specific, just Falco installation, pretty straightforward. And what I'm going to do now is that I'm going to start a small program that I created to get some events spawned. So basically, you can see all kind of events here popping up. See if I can move it a little bit more. And I'm going to here open up a tail. Let's do a color tail, it's always nice. And let's say that I want to write below a binary directory. You don't want that in your container, right? You don't want any writing below binary directories or something like that. So let's do that. And I see that there is an event right away spawned from syslog, error file known binary directory renamed removed. I can also go, for instance, like modify LD preload files, see if that's happening. And basically, there is a lot of information that I can directly get out of it. For instance, also, what's important case for containerization environments nowadays is protect against crypto miners. Let's take a look what crypto miners can do. And I can see directly here that critical possible miner running in there. So you may think that this is all set up by me and I'll program it or something like that, but Falco comes out of the box with quite a number of rules. So if you install Falco, all these rules that you see, all these events that are getting spawned are default. You do have the possibility to create your own rules additionally to that, but there's an extensive set already available. Let's go back to my presentation for a moment, see what we can get there. Okay. Share it again. A bit more detailed structure. So this is how Falco is functioning. The syscall events that we just saw is going to be one of the Falco sources, as you see here, and then it's going into the rule engine. So the rule engine is basically determining what's happening in the system. Is this worth of being spawned? It's checking the syscalls, all the syscalls relevant, and that is basically spawning an alert via gRPC file, standard out. We're using now syslog, HTTP, but we will get to that in a minute. So how does a rule look like that? This is how a rule looks like. So we took a rule here from the top, warning symboling created with a sensitive file. We see the command ln-sf etc shadow 2/tmp/marcel. So I'm copying a symbolic link of the shadow file. So how does that rule then look like? So a rule always has a few constructions: the rule name, description, the condition. This is basically the part where it's all about. The condition is where the syscalls are interacting with the Falco engine to get all the details. And then the output, and basically the output is just a resemblance of what do you want to see, in this case in your syslog file. We're adding a priority, and we can add some tags. And tags can be important for your compliance, because maybe you want to be GDPR compliant, and that's one of the reasons that you need to have that, so you can add a GDPR tag to that. If you take a look at the condition here, you see that there's a create symlink and sensitive file names, and there we are using macros. So macro basically can be used to tell, to ease up the use of rules. And you can see that this macro create symlink. That's a condition that event.type is in, and then you see the symlink and see symlink add as the syscalls that are being detected. Event directory in, so it's an input file, so we need to have that information. We can also make use of lists, and basically lists are basically giving you the possibility to, for instance, target the sensitive file names in this case, giving you an overview like my sensitive file names are etc shadow, sudoers, pam.conf, and the pbquality.conf files. So basically, if any of those files is being touched, as being a symbolic link is being created, you get an alert being raised in your system. So this is basically how you set up a system. It's a very basic rule. You can extend it very much. But there's also a large community maintaining those rules, so you don't need to set it up yourself. Probably the rule that you want to set up yourself is already done by someone else. So copy it from the community, add it to the local Falco rules, and you're done. I have some popular rules here, like for instance best practices. Update package manager, modify bin user. Well, I'm not going through all of them because you read yourself. Privileged container is a nice one. Privileged shell, terminal shell, so compliance parts, like we want to know if kube control exec attach is being used. PCI NIST frameworks can be used. Some known vulnerabilities that we know about, like the top one, kube control copy, right? That's or the container escape vulnerabilities. That's all being part of rule set of Falco by default already. From the cloud native stack, and that's basically we see that we have Elasticsearch, Redisk, all that kind of rules are directly supported by Falco. What else can you do besides going into syslog calls? We only had it over syscalls, but that's all reduced to the local level, right? In some cases, you don't even have access to syscalls, but then you need to have other precautions. But we also have the possibility to extend Falco with plugins to use other sources, like the bottom part seen here, Falco plugins. Initially, Falco was only using syscalls and had a few built-in plugins, like the Kubernetes audit logs was default plugin, and the AWS CloudTrail was also default plugin. But that were basically the only plugins that you could use in the Falco system. Since last year, we built a complete new system that allows us to use plugins in generic. So the Kubernetes audit log and the CloudTrail, of course, moved to the other sources. The Falco plugins are going into the rule engine, and of course, different rules apply for an AWS CloudTrail or anything like that, but they are going into the same rule engine. What do we provide for rules now? This is just a simple example. So AWS CloudTrail, we have Azure Log Analytics, GCP Cloud Log, Kubernetes Audit Log, as I already said, Docker, Twitter, Okta. Basically, every streaming instance can be added as a plugin to Falco. You can build your own rules around it, and of course the syntax is a bit different because for a streaming instance it's different as from a syscall instance, but it's easy to write your own rules. Output file. So I already noticed that we do remote procedure calls, output file, standard out, shell, HTTP, but it's all pretty straightforward. The text that I've shown you, right, not very well readable, so that's a little bit difficult. So as we take a look at output files, then we would like to take a look at Falco Sidekick, for instance here. Falco Sidekick. Falco Sidekick allows you to add external output regulations. So if I go to the overview here, it collects the Falco events not only from the node where it's running on, but from multiple nodes. You can use the Falco Sidekick as a collector for all the events that you get there, and you get all the output where you can forward it to, for instance, a Slack. You can do it to Teams as a notification area. We can use also Spider-Bat for our Node-RED for some SOAR capabilities. Or you can do CloudWatch log, feed it back into CloudWatch. So basically, I added a number of them in the bottom part, but the list is much longer. And so basically, it's very easy in Falco Sidekick to configure sources. Okay, so let's take another look with that same Falco instance, the same stuff that we did just a minute ago, but then we are trying to get into Falco Sidekick. See if I can get out again. Okay. So, starting the containers. So basically, this is the containers required for Falco Sidekick. I'm doing some reconfiguration with from. And what I see is Control Active. So just showing you what the differences is to enable Falco Sidekick as an output mechanism. So I'm going to show you what the original Falco file was, the configuration file, and what the new Falco configuration file is. And you see that basically I only set a JSON output to true. So basically instead of bare text, I'm using JSON output. And I enabled the URL to some URL to localhost 20.0.0.2. That's where my Sidekick instance is running. So if I now go to starting that same instance again, run. You see already at the bottom part, oh, my color tail core dumped, always nice of course. You see already now that what happened is that the output changed to JSON. I'm getting all the information here, and if I now spawn a thread, attempt being used to modify directory, and let's see if I now also have my Sidekick running. Where is it? So this is the Falco Sidekick console, and you see now that information is being spawned inside Falco Sidekick. So basically, it's giving you a good understanding of what's happening. It's giving you an overview of what can be done and what should be done. And you can filter and search for all the information that is in your, what was the output of your console. So let's take a look at the dashboard. It's giving you also priorities. And if I now do, let's say, let's try kill known malicious process or something like that. Events, file below, opened for writing, paste bin kill. So apparently the event is directly spawned into Sidekick. And from here on, you have the possibility to also configure your sources like Slack. I think I also set up Slack. I got a notification, as you can see here. And you see here that my notification, like the file below a known binary, is also spawned to Slack. So basically, this is showing you how easy it's set up to get into Falco sources, to the rule engine, output via Sidekick, for instance, to several sources where you can get directly your thread events inside the different platforms. This is basically what I would like to show you. Would like to thank you for your attention. If there are any questions, then let me know. And for more information, falco.org is your source. Yeah, go ahead.
Thanks. Can it just report threats or also prevent them?
Sorry, what was the question?
Can it just report a threat, or can it also prevent it? For example, prevent a symlink?
Now, Falco is a runtime threat detection engine on its own, right? So we can use SOAR capabilities, as I mentioned. So you need additional tools to do the remediation, killing containers or anything like that. Yeah.
Basically, the sidekick of Falco, basically what it is doing, it is a sidecar which produces a RSS feed, if I understand correctly. Something like that or not?
So, I'm not sure if I understand your question right, but what Falco Sidekick basically is doing, that the Falco engine is rerouting all the event messages to the processor of Sidekick, and then Sidekick is basically the receiver of the messages and responsible for spawning it to, for instance, Slack. And what I also did, and that was the tool that I've shown you, is Sidekick UI, and that's basically the follow-up of Sidekick. So Sidekick is spawning to Slack and to Sidekick UI in the example that I've shown you.
Yeah, so basically it's a feed, and then whoever is the consumer, they can consume that feed and then get...
Correct, yeah, correct. Yeah.
Hi, I was wondering if you do not enable eBPF, what are the downsides if you just use it without that?
So it's either eBPF or kernel probes. So you don't need both of them. One of them is sufficient. So by default, the Falco installation is using the kernel probes. If eBPF is available, it will use that one. But you have options to configure that.
Okay. What types of threats do you usually find, and what types of environments?
Yeah, okay, that's a good one. So basically Falco is, so I'm working at SysDig, right? So SysDig is the enterprise platform around Falco. So we do see, and the enterprise platform around Falco, we're using it as a runtime threat detection engine in SysDig. And the main threats that we see is a lot of private shells being spawned inside containers. If you talk about the threats from the outside, inside is often a threat, maybe not a real threat, maybe false positive, that's going into kubectl, someone spawning a terminal shell in a container just to take a look if the environment is okay or something like that. But the most threats that we see from outside is more on starting with a privileged shell from the outside, like for instance, when starting with log4j or something, you get a privileged shell and the follow-up actions, because the privileged shell on its own is not a threat, but the follow-up actions like curl and starting a netcat or something like that, that's the real threat. So basically, I've shown you single events, but in most cases, it's a chain of commands, right? So not only one.
Yeah. Marcel, we have one last question, is that okay?
Hi. So is there an option to forward, I saw that Falco can be deployed like a daemon set or something to collect the logs from each host. So is there an option to ship the logs to something like a syslog collector without the sidekick? Or do you need this as an intermediary to collect the logs and then forward it to something like Splunk or Datadog or whatever? Or can you just lose like a syslog exporter directly?
Yeah, so by default it's syslog and the output that I've shown you, right? So remote procedure calls, HTTP, so that's by default in Falco. And for alternative options, you need to have the sidekick installed. Okay, thank you very much.
Yes, you can take it. Thank you very much, Marcel. It was definitely interesting by the number of questions and the number of questions that I didn't let go. Ladies and gentlemen, we are going to have a 12 minutes break. We're going to restart at 10:45 here. No, sorry, at 11:45. I'm Italian, so I got my times wrong. One thing that I must ask you, there is a workshop at the moment running, is that correct? So please, when you go downstairs and go outside through the smoking area left, and there you will get in from the sponsors area. Thank you very much. We'll see you again in a little over 12 minutes. So how's it going so far? You enjoying the speakers? I think they're amazing. All right. Do you know, guys, the one from the Italian, the German, and the English that walk in a bar? No, I'm joking. I'm just not going to talk. We have Salman from Appvia. Please give it up from Salman.
Give me 1 second. Ooh. Okay, welcome everybody. Good morning, Amsterdam. How are we all doing? Yay! This is the last session before lunch, so we'll try and keep it light. Right, imagine you have a website. Could be any website. And there's some traffic coming to it, and it's working fine. But at some point, you launch a new product, I don't know, iPhone or whatever, and there's a lot of people coming to your website now. And there's not enough traffic being served, and people are not happy. What should happen is that we should use what Kubernetes has been promising us, right? The autoscaler, you can autoscale it. But it doesn't do everything by default. There's some work that we have to do in order to do that. And that's what we're going to look at today. How do we autoscale based on some events and basically scale out the website and let people do what they need to do. But before we start, because you've all come here, I thought we should reward you with something. Everybody know this Tux, right? The Linux Tux. It's a Lego. I have this Lego right here. We like Lego. Who likes Lego? Yeah, but everybody's not going to get it like that. You know, there'll be a bit of a quiz. Just one question. Shout out the number. People know about the landscape, CNCF landscape, the CNCF landscape. No, not that one. This one, right? So this landscape. This shows, you know, we were talking about, Sarah was talking about it this morning about choices and how many choices we have. There's a lot of projects on there, or cards. So here's a simple question. The question is, how many cards are on the CNCF landscape? Some of you might already know this, but I'm not unreasonable, so I'm going to give you a bit of a hint. This is what 20 cards look like, right? So that's 20 cards for Service Mesh, right? So here you go. Shout a number. Whoever's closest, William here will give you this. So just shout a number. 400, higher. 600, keep going up, keep going up. What was that? 1,000, keep going. 1,200, I think, let's stop here. 1174, that's very good. A round of applause to that gentleman there. Can you just pass it on? 1174, enjoy the Lego. I don't know how long it takes to make it, but apparently the instructions are as good as what we see. So just a few more things. So that's 1174 projects on there. I'll just put out some more stats on here. It's as of last night. 3.6 million stars, but more importantly, like countless of community stars, right? People who are working on these projects in their own time. So great, and some of the other stuff there. So this was as of last night, 1,174. But when I woke up this morning, it looks a bit like this. It keeps increasing every day, right? So I know you're a bit disappointed that you didn't win, maybe that Lego, but don't worry. I work for Appvia, and we have a booth downstairs if you'd like to win some of this stuff. We have some cool stuff, so just come through. We are downstairs. The Mark, Lucy, and Rory are down there, and I'm going to be myself there, so if you want to come and have a chat. I work for a company called Appvia as an MLOps engineer, and we are a startup. We are a consultancy. We also have a product that helps you deploy stuff to cloud easier. And I also work as a Kubernetes instructor for LearnCades. Check out our website, learncades.io. And we have a bunch of blogs. You can find me on Twitter at SoulManicBar. I also have a bit of a YouTube channel. You can check that out, SoulManicBar. So that's Appvia, appvia.io. Check us out. I had to make sure I put that there because I need to get paid. So we're done with that. But yeah, so that's my YouTube channel. Just check out my YouTube channel. But before I start, really want to thank the hosts and the organizers. You know, they've done an awesome job putting an event together. Would you agree with that? Yeah? Yeah. Thank you so much. So, and also I want to thank my friend Daniele Polencis from LearnCades who helped me put together this presentation. So thanks, Daniele. So here's what we're going to do. Brief look at services and a quick look at ingresses. I'm sure you're already aware of what those are, but just to make sure we're all on the same page. And then we'll look at CADA. How do we auto-scale it? And then I'm going to show you how to auto-scale the ingress. Whatever I show you, even though we're going to scaling the ingress, you can also apply to any other workloads that you have. So it should work fine. So imagine Just a bit of a quick recap. This is, imagine you deploy a website, and it's just a static page. And if you want to deploy this in Kubernetes, usually you deploy the website and you have to stick in a load balancer because you need to make sure the traffic is distributed evenly. And you can have multiple load balancers because you might be running multiple applications inside. And then if you're running multiple applications, you want to make sure you route the request based on the request that they've sent to. So in Kubernetes, as we all know, the internal load balancers are services. They pick the right pod to send. And then the top layer load balancer is called an ingress. So this is sending requests from outside the cluster to inside the cluster. And then we have pods. I'm sure we all know this. So this is what it is. We're going to focus on ingress today. But before I can talk about ingress, it's important to just point out really quickly what services are and what are the limitations of services in the context of running websites, and why do we need ingress. So every time you deploy an application inside a pod, a container or multiple containers, gets an IP address. And then we use service as an abstraction layer, because it's convenient to have an abstraction layer. If you send a request from another pod or from outside somewhere, the service knows how many pods live underneath it, and it can basically you send a request to the service, and it's an abstraction, so that makes a request, and only the service knows how many pods are running. So you could have two, and if a pod dies or comes back up, it doesn't matter. It will keep track of it and it'll pick it. And if it goes up to 10 pods, up or down, doesn't matter. The pod that is sending a request doesn't need to know anything. It's the service that needs to know it. So that's very high level service definition. If you would ask ChatGPT, I guess that's what it would give you. But there's different kinds of services. We have a headless service. That's a building block and the most basic service. It's basically like, all it is just an endpoint, the IP address. It's not very good with load balancing. So what Kubernetes also provides is the default service. So if you create a service in Kubernetes, cluster IP extends headless, kind of like a load balancer. So it does a better job than headless for load balancing. Then we have, so the two services so far, they're all internal services. You can't expose it to the outside of the cluster. So then we have this thing called node port, this external service. It basically opens a port on each node. But you might have multiple nodes running. So what Kubernetes provides is another kind of service called the load balancer service. And it just has a node port. And if you're in a cloud provider, it provisions an actual load balancer and attaches it to the nodes. If you're doing this on premises and you've used a service type load balancer, you have to have some kind of a project like MetalLB that allows you to do that. But it's kind of useful if you're doing it with a cloud provider. But there's a couple of things. There's a few gotchas with services. A good thing is that it automatically provisions the load balancer. So we're talking about external services because we want to make sure we can access the website from outside of the cluster. It's automatic provisioning. It provisions the nodes on the ports and attaches it to the load balancer. But as I said, it's cloud provider specific. If you're doing on-premises, there's extra work you need to do. And I don't know if you have done this. I'm pretty sure you're aware. Cloud providers are not cheap in the cloud. Load balancers are not cheap in the cloud provider. Imagine if everybody is spinning up a load balancer for their application. Could cost a lot of money. And the limitation is it's basically just layer 4. If you wish to expose services that use TCP or UDP, services are good. Your application is good. So this is where we need something like this, an ingress. Something that can understand HTTP requests and can deal with it and send the request to a service. And that's why we have this service, we have this ingress that sits on top of service. I'm sure you all know, but that is what it is. What we can do with an ingress is we can route traffic based on the requests that we make. For example, I have this cluster with multiple applications, the red, the green, and the yellow. And you can do path-based routing. So if somebody says example.com/account, send them to the red pods. If somebody says /checkout, send them to the yellow pod. And so this is where ingress comes in quite handy. Or also you can do subdomains. Like if you need to do domain-based routing, you can do all of this. So that's what an ingress is, right? So that's the ingress, the pointer of an ingress. Everybody happy so far? Are we all good? Okay, cool. So far I've shown you ingress as just a black bar. That's all it is. And I'm sure you already know this. It turns out that an ingress is just a deployment, a regular deployment of, depending on the type of ingress controller you pick, there's different ingress controllers, and a service, usually load balancer or node port, because it's like external service, so you can expose it. And in this diagram, you can see that the black bar has disappeared, and now we have this service, load balancer type, and we have an ingress pod. In this case, we have Nginx. You can pick any that you like. There's many, and there's quite a few which ingress controller you should pick, depending on what your requirements are. There's some research out there that you can check out on learncase.io. So it's basically a regular deployment. An ingress comes in two parts. You have this thing called the ingress controller, basically the pod that's running, that understands what to do with the rules that you write. And the rules are those ingress manifests that you write. These YAML files, right? So these YAML, people written this ingress YAML file before, right? Yeah, have people written it? One person has in this room. I'm sure there's more than one. Good, excellent. People written this, right? So an ingress is writing the rules of defining what should happen to the request. Where should it go to? Which service should the request go to? So we write this YAML file and we submit that to the Kubernetes cluster. The cluster takes that request and it stores the information inside an etcd database. And we have a couple of components in here. We have a scheduler, we have a controller manager, but that information goes ahead and gets stored in the etcd database. That's where we store the state, the desired state, and the current state, and the controllers do their magic and make sure the current state always goes closer to the desired state. So that's what it does. But when you deploy this rule, the ingress YAML file, the cluster itself the ingress pod, the controller, will spin up. It will get the information from the ingress, because etcd, and it will configure the rules. So Nginx config, if you use Nginx, it will configure the rules in Nginx config to say, if this is the pod, you need to send the request to this service. That's all it does, right? And then it will just write, or if you write another ingress, it will take that rule, it will update its config, and it will understand this. So here's the thing. If you're running a website, so that's ingress and service, and that's our backstory. But if you run a website, now we understand the request has to come from outside of the cluster. So it has to go via the ingress pod. In this case, it's Nginx. If it goes via the Nginx pod, and if a lot of traffic comes in, you might end up with a bottleneck if you have just one replica running. You might say, hey, what should happen is that if a ton of traffic comes in, we should scale out. You might say, oh, maybe I can just start with 10 ingress pods running at all times, which is fine. You can do that. But of course, it's going to cost you money. So if you want to save some money in these times, especially in the UK, because the pound is very down, we need to make sure that we can scale down when we need to. So what you can do, as I said, in ingress, the deployment is a normal deployment. You can configure this if you deploy it in your cluster as a Helm chart or whatever it is. You can configure these settings. You can change these settings. You can say, there's a file in here, there's a line in here called replicas. I can open the file, change it to 3 replicas, and submit it to the cluster, and I'll have 3 replicas. But it's not very scalable. It's not very, maybe you have to wake up at 2 a.m. in the morning. Well, we need something good, right? We don't want to wake up at 2 a.m. in the morning. We want it to happen automatically. So this is enter our helper, the horizontal pod autoscaler. It's a resource in Kubernetes that scales out the pods. The vertical pod autoscaler is different. It changes the CPU and memory, so it can increase more CPU and memory for it. Horizontal pod autoscaler spins up more pods. So you can see this, in this case, what should happen is imagine there's a deployment for the ingress. We deployed this ingress controller in our cluster, and it's running with 3 replicas. What horizontal pod autoscaler can do is it can query some metric. Let's say number of active connections inside each pod, right? That sounds like a reasonable metric. Let's say it can query that metric, and we can write a rule. We can say, hey, if each pod has got more than 100 connections, we need to scale up. A reasonable request, let's say. Then what horizontal pod autoscaler does is it will do its calculation, and if you breach the threshold, it will automatically adjust the deployment. And it can scale up, add another pod, and scale back down, and remove all the pods that we don't need. So what we want to do is scale based on incoming traffic. With me so far? Everybody good? I know it's 15 minutes to lunch, so we're on track. Don't worry, we're on track. So what we want to do is we basically want to scale on HTTP requests coming in, basically requests coming in. But you can do it on any metric you prefer. In our case, we will just do it on, let's say, active connections. So first of all, we need to have metrics available, and we need to expose it so the horizontal pod autoscaler can take those metrics and do something with it. So usually you would write in your application, you do /metrics, and you can write key value pairs in there, and just in your application make it available. So something like Prometheus can scrape it. But we take that metrics, we need to store those metrics, because the requests have to come over time, we need to store it, just run our calculation, and then once we store it, so collect and store it, and then we're going to do auto-scaling. We have, based on those metrics, we'll write some rules and we'll auto-scale. And this is what you see in the demo as well. So what we have is, luckily for me, makes the demo easier, Nginx provides already some metrics. That's so I don't have to write anything from scratch. Nginx pod has /metrics. It provides these metrics. In here, we can take this metric, Nginx connections active. So this is all the connections coming in. That's what we're going to take. They're available, but we need to scrape the metrics. So what we can do is we can use Prometheus. People like Prometheus here? Anybody like Prometheus? Yeah, it's a great project, right? So we basically, what it does is it helps us. You have something called a metrics server in Kubernetes that can be used to pull out the metrics from whatever resource that we want to pull out from. Takes it out from kubelet and provides it to other resources like horizontal pod autoscaler. And this is where we can use Prometheus. Prometheus allows us to do that. In Prometheus, we can scrape the metric and then store it wherever we like. In this case, we're going to store it in something else. But what we're going to use is Prometheus. You don't have to use Prometheus. But in this one, we're going to use Prometheus. And I have a cluster that's running locally, which has Prometheus already installed. And then we're going to use this project called KEDA, or KEDA, Kubernetes Event-Driven Autoscaling. Have people heard of or used this project? Oh, yeah, excellent. We have quite a few people. So if it gets stuck, you can come up and give me a hand if the demo doesn't work. But it should be good. So here's the thing. We need to expose the metrics. We need to store them. So we can scrape it using Prometheus. We need to store the metrics. And then we basically need some kind of an adapter that can take the information and feed it to the resource metrics so we can act upon that. And then we need something that scales based on requests coming in from wherever they're coming in. And this is where we can use this KEDA, Kubernetes Event-Driven Autoscaling. I'll show you in a second a couple of diagrams for what it looks like. It lets you basically drive the autoscaling of Kubernetes based on events. Events that happen inside the cluster or events that happen outside the cluster too, which is amazing. If you have a bunch of requests outstanding in a Kafka queue, you can scale on that. So there's a bunch of scalers that KEDA already provides that we can plug into. Even stuff like SQL queries. Run an SQL query. If the result is above some number, do something with it. So that's where we're going to use KEDA. What we can do is it's quite flexible. It's open source. And it drives the horizontal pod autoscaler. Something needs to feed all this information to the horizontal pod autoscaler to be able to scale it. And that's what we're going to use KEDA. What is it? So we have the metric server, as I talked about before, just briefly, is used to collect metrics from kubelet. So the kubelet that's running on each node, it collects metrics from there and exposes it to the Kubernetes API. And it plugs into the aggregator API, but what we have is this metric server. It's not enabled by default, so you have to enable it. But when you install with in KEDA on the cluster, it will be enabled. And then we need an adapter. It's, Prometheus adapter, same. KEDA also provides one. It can collect and serve custom metrics and external metrics to the horizontal pod autoscaler. KEDA has it. And a controller that sits in the cluster and acts upon the events. So that's what we need. So if the controller is there, we're going to have a bunch of custom resource definitions, so things that KEDA defines. And I'll show you an example of that. And controller is something that extends Kubernetes and does a functionality. And then we have what are called scalers. We're not going to talk about them today, but this is, I briefly mentioned it. You know, if you, for example, you can define some rules based on requests coming in from RabbitMQ. You can scale out your application. Or there's a lot of CloudWatch events like AWS CloudWatch, anything in PubSub in the cloud provider. It's very neat, and it's quite easy to set up. And so this is where Keda comes in handy, and that's what we're going to do a demo on. So we have 10 minutes. So a lot can go wrong in 10 minutes. So that is the demo. We're going to do live. If it fails, I have a video as well. But we'll pretend it was live if it fails. But I'm sure it'll work. So you can, if you want to check out, Danny Elliott wrote the blog for this bit.ly/KCD scaling. It runs on Minikube. You can run it yourself, or you can run it in any cluster you like. So that's where explanation and the code and everything's there. So definitely check that out. So what I got, which I'll show you in a minute, is a Minikube cluster. It's running. I've installed Nginx Ingress on it already, because I do not trust the internet during demos, so it's already running. And I've also installed Prometheus and Keda. I've used Helm for it, but you can install however you like. It's just one command line, spins up the pods. I'll show you the pods in a second. And then what we need to do is we need to have a way of generating some load, right? Because otherwise you'll think I'm making it up. So we're going to use a Locust. It's an open source project to just generate some load. And hopefully, if everything works, we should see auto-scaling ingress. So are we ready for the demo? Yeah. Let's mirror. We'll give it a second for it to pop up. All right. We're cool here. So here's a few things that we got, which I'll actually put in around. So this is all real. There is a deployment file. I've deployed Stefan's pod info pod. I'm sure you've seen this. It's running, and everything is running locally. I trust the internet, but not during demos. So everything is running locally. So that's the pod that's running. It has a service, of course, as well. So pod and a service. I don't know if it's big enough. But let me, is that good? Reasonable size? Cool. So we have service and a pod. That's already deployed. And we have an ingress. And in ingress, you can see there's a bit of the rule here. Example goes to example. If the request is for example.com, send it to the pod info service. So I'm not making any of this up, because if I can do a clear k get pods, you can see in a second there's some stuff running. So we have our deployment here, the pod info deployment. We have Keda. I've also installed Keda on here. The operator is running, and we got a bunch of CRDs to go with it. And we have pod info. We have Nginx Ingress running, and we got some of the Prometheus stuff. I know no Kubernetes demo is complete without running kubectl get pods, so I just wanted to get that out of the way. So that's done. Now we don't have to look at this. Instead of me showing you lines, we have a dashboard here, right? So these are all the pods that are running in the cluster. Let me see if I can zoom in. These are all the pods that are running in the cluster. It's not a photo. It's an actual dashboard. And we have one Nginx pod running. So that's all good. I'm going to put that to the side. And we're going to step onto here. And Prometheus is also running. We got 5 minutes, which is good. That's all we need. And let me just quickly zoom out for a sec. If I execute this is Nginx Ingress active connections. Basically what we're talking about. You can't see this is quite small, but there's only one request, because there's only one request that was running. And then what I've also deployed is Locust. And Locust is an open source project. Let's just open this. And all it's got its own deployment. But in here, you can define a config map. And the config map, we're defining, you have this locust file.py that's written in Python, but you can give it a task. And all this is doing is allowing me to send requests to example.com. That's all it's doing. I want to send requests to example.com. And because it's locust, I can do a bunch of things. I can give the host that I need to send a request to how many users I want to send per second, and so what we can do is we can start swarming the host. We can start sending requests. Let's hit on the chart. I don't know if it's, let's just do this. Is that, stop. There's some things about to go wrong, bound to go wrong, but let's go. Here you go, charts. Okay, so let's go 100, what was it? just going to stick here. And also what we have is, let's go with that. I think I need this Nginx ingress. And spawn concurrency is 10. So it should start sending requests, right? So it started sending requests, and I should see some of the requests go up on here. In a second, we'll have more requests for ingress active connections outstanding. So if I just quickly do a refresh here, sometimes it will come up in a second. So basically what we've got is number of users are increasing, and requests are going in, and the response time will keep going up. But what we need is to scale up. So for that, we have to define this something called a scaled object, which is a CRD. And in here, I'm saying what kind of deployment I want to target, the main Nginx ingress deployment. And I just define how many replicas I need. And we're gathering metrics from Prometheus, because that's where it's scraping it from. This is the one I'm looking for, the metrics name, that's the name. And the query is this. All we're saying is if the Nginx ingress connections active is more than 100, so that's the threshold, do your scaling, do your thing. So let's just see if I can execute this. You can see in here, it's a very faint line on the edge there, but there's a number of requests that are going in. There's only one. Now we're going to focus on this part here. What we'll do is deploy the scaled object, and we should see number of Nginx pods increase. If it does, go wild. If it doesn't, still go wild. Let's do this. We're going to do a -F4. We'll apply the scaled object. And what this will do is, okay, that's created. And what this will do is you'll look at the metrics, and it will start increasing get deploy. Let's just do that. It should eventually start increasing the number of pods. Let's just make sure. Ooh, here you go. The pods have started to spin up, and it'll spin up based on the request that we said, right? So now, yeah, we got it working. We got there. So this is, as you can see now on here, the total number of requests are going down because we scaled up based on the request, based on an event. And if I keep this running, once all the traffic's served, it'll scale back down. That's where the scaled object is. And you can do this for not only ingress, you can do this for any workload that you might need. So I'm just going to do one last thing. If you want to, let's just hop back on this. Okay, where's my pointer? Let's go in here. Let's go. So that's what you saw. You saw us gather some metrics, and we just talked about services, ingresses. Then we exposed some metrics, and we gathered them. Kubernetes doesn't do this by default. There's a lot of work we have to do to get all of this running, and you saw that. If you want to try it out, as I said, it already is a blog for this, bit.ly/KCD scaling. Check out learncase.io. We have some awesome blogs on Kubernetes, and we do some training as well, so check that out. Also check out appia.io. If you have any questions or anything like that, I'm downstairs all day. This is our booth in one of the areas. Come and grab me. Let me know if it was useful or not. If you want to stay in touch with me, my name is Salman Iqbal. You can find me on Twitter as Solman, or also YouTube. But apart from that, thank you so much. Have a great day and a great conference.
Thank you, Salman. That was pretty intense, very good. The demo gods have been listening to you. While I was watching Salman, I started thinking of an experience I had. Excuse me, people that are leaving the room. One thing, there is a workshop going on. Please go outside to the left to the sponsor area. Lunch is going to be in the sponsor area served, and lightning talks in the workshop area. So back to us. What I was thinking is, I always thought I am a very intelligent guy and above average, certainly the average in this room. But I realized it wasn't the case when I had to marshal YAML into Go. Anybody knows what I'm talking about?
Yeah.
Yeah? Did you hate your very existence when that happened? Yeah? There are online, true, there are online tools. So that's what I thought. I thought, why shouldn't it be an online tool? So I went the stupid way. That's when I realized that I'm not above average, I'm quite below. And I wrote my very own tool to Marshall. 2 days later, a colleague of mine said, but I use this one online tool, and yeah, you're not very kind. So anyway, thank you very much, Solomon.
No worries.
It was very good.
Thank you.
And what I would like to invite you again, guys, please let the workshop guys go on. Go through the smoking area outside, grab a smoke if you like, or don't, and then you go through the sponsor area. There you can grab your lunch, is going to be served. We're going to be having the lightning talks in the workshop area, and I'm going to see you here at 1:45 at 1:45 with Robin Sipman from ING. Thank you very much. Kun, can you please give us the screen for a moment? We want to test one laptop.
Hey, hey, hey. Okay.
Now everybody hears me.
Perfect. Yeah.
Thank you. Okay, good afternoon again. We are going to have a few sponsors talks, and we have Sergio from Enterprise DB talking us about SQL and why not to do it on Kubernetes. No, I'm joking. Why do it on Kubernetes? Thank you.
Hi everyone, Sergio Mera speaking. Today we are talking about Postgres and how to run Postgres in Kubernetes. Okay, we'll spend 20 minutes. I split the presentation in two parts: 10 minutes of presentation and 10 minutes of a demo to show how we can deploy a Postgres database or a Postgres cluster in Kubernetes. Okay. This is some lines about me. I have a lot of experience in databases. I've been working in Oracle, in BNP Paribas, a French bank, and Quest, and other many companies. 2 points today. Why did Postgres win? It does everything. It means that we can have different use cases depending of your company. And it works everywhere. Today we'll be concentrated just in the containers part because it's a Kubernetes day, a Kubernetes community day, and this is something that I want to show you. Okay. So, what is a Kubernetes operator for Postgres? If I resume, I've put in yellow this phrase is an operator that can simulate the work of a DBA. I don't want to replace people, but this is something that we know how to do, and this is something that the operator can simulate in your Postgres databases. Okay, so what is Cloud Native PG? Cloud Native PG is our operator that has been created and donated to the community 1 year ago. It's an open source software, and you can use in your environment, in the dev environment, in test environments, and production environments. Okay. Originally, it was created and developed by EDB, but again, we have donated to the community, and you can develop and you can contribute to this project if you want. Okay. Another important point is that this project and this product is production ready. You can use in production. Okay, no, it is not necessary to ask to EDB to use this software. Okay, we have created a portal, okay, a web portal in which we have documented all the project, and you can follow if you want. You can start here if you like this product. Another important point is don't forget to click if you like it. Okay. The demo that I'm going to show you in 10 minutes is about an architecture that I put in Kubernetes. Okay. This architecture will create, or this deployment will create in Kubernetes a Postgres cluster with one primary database and 2 standby databases. Okay. Of course, this database is replicated to the 2 standbys near to real time or in real time, because we can activate a synchronous or asynchronous replication here. By default, there are 4 services that are created. One service to be able to connect to the read-write database, another one to be able to connect to the first standby that is synchronized in synchronous mode, another one to be able to connect to both standbys, just to read-only databases, another one that can point in all instances that are created in the cluster. You can deploy the cluster in several nodes, and of course, your application can be connected through the services to the databases. What features I will demonstrate during the demo? First one is to install a plugin. I will create a cluster with the plugin. I will insert some data that you can query if you want, or I will query the data to demonstrate that all the data are inserted in the database. I will show a switchover, a failover, a backup, a recovery, and I will do also a rolling update, a minor rolling update during my demo. As you can see, there are a lot of things that will be demonstrated only in 10 minutes, okay? And this is part of the job that a DBA is doing, and a DBA has learned during many years, okay? A DBA is not something that we can put from one day to other. A DBA needs to have a lot of knowledge about databases to be able to do all of this task. Okay, in my demo, I will demonstrate the creation of the cluster. As you know, to create a cluster, everything is written in a YAML file. So in my example, one primer to standby, Postgres 14.2 is not the last one. Okay, it's just to demonstrate that we can upgrade from one version to other. One minimum, the primary instance will be synchronized with minimum one database in sync mode. Okay, 1 GB of disk and two CPUs and requested 1. Okay. And that's all about this file. Let me just show what is the final architecture that we will have in our cluster. In our cluster, we'll have a cluster that is called cluster example read-write. And this cluster will have several pods with several PVCs, physical volume claims. Of course, the data will be replicated each time that a data is inserted in the primary cluster. And at the end, we will have an architecture ready for production, okay? And that's all about that. Let me show you one example. We have a customer that is using Cloud Native PG in France. We have many customers in the world, but I take this example because it's a good one. La Poste is using Kubernetes, is using OpenShift, and as you know, Ansible Tower is using Postgres databases in the backend. Okay, so this Postgres database has been replicated in high availability in 2 clusters. Okay, in one cluster like a main cluster, and another to have a disaster recovery solution. So this is the result of our production environment with this customer, which is, of course, very happy to use this kind of solutions because they want to implement our solution to have a solution in disaster recovery. Okay, let's go to the demonstration. I have prepared an environment. Okay, I have here my console. Hope that you can see my screen. So the demo that I will run is very simple. I have created some scripts. All the scripts will be executed in order, 1, 2, 3, 4. And each time that I execute a script, there are 2 parts in the script. One part is the green part, the green code that is written here, which is the command that I am executing, and the white part is the result of the command that I am executing. To install the operator is very fast. In some seconds, the operator is installed in my platform. I'm using Docker in my laptop, you know, okay, with Kubernetes features activated. The second step is to verify if the operator is installed. Just let me show you the command. It's just okay, this command that is executed. In the first step, I'm verifying if the operator is installed correctly, and is installed correctly. You can see that the operator is ready. I have created a template file with the script number 4. Let me show you the template, okay? Cluster example.yaml. This script is the script that I showed you before. In this script, you can see all the definition of my cluster. My cluster is a cluster example. I have 3 instances, version 14.2, minimum 1 replica in sync mode. Okay, remember that we have 2 standby databases, some parameters in Postgres, storage 1 GB. I'm enabling monitoring, and my limit CPU is 2 CPUs. One thing that is very cool is that we can allocate fractions of CPUs, okay, with this technology. So, okay, let's go to apply the file. Before to apply the file, I'm going to execute the number 6 here, which is the status of my cluster. So I apply the number 5. Oops, sorry. Okay, so I have executed the script number 5. Script number 5 just will apply the cluster example YAML. I'm creating some secrets also for my object storage that I will show you again afterwards. So the creation of the cluster, it takes around 1 minute. And in 1 minute, what the operator is doing is instantiating 3 instances, 1 primary and 2 standby. The primary is already here. The operator has configured all the certificates for replication. He's synchronizing the primary database with 2 standbys. It means that all the data that will be created in the primary will be synchronized in real time with the standbys, okay? And at the end of the process, the number here here we go, we have 3 ready instances. Everything is in green. It means that everything is under control from the operator, okay? So before to continue, I'm going to insert some data, just to have some data in my database. Before to continue, I'm going to start an object storage environment, okay? Because I want to create a backup from my database before to continue. To do that, I have created a container that I'm going to start. It's a Minio container that enable my object storage platform, okay? So my object storage platform is here. I'm going to put my login and password, admin password. Okay, sorry. Okay, so by default, I have nothing in my bucket because I have not configured already my backup in my cluster, but I'm going to do that, okay? In the script number 9. Before the number 9, I execute the number 8. And the number 8 is a switchover, okay? How to promote a server. So here you have the script that will promote my standby database, my first standby database, this one, the number 2, as a primary, okay? By default is the number 1, but with this script, I'm going to promote the database number 2. Okay, so you will see that in 2-3 seconds, I can do a switchover. So what does it mean? It means that my primary database will not be anymore the number 1, it will be the number 2, okay? Number 8, promote. Here, the cluster will be off during 2 seconds. I have a refresh of my console every 2 seconds, okay? And here, you have, as a primary, the cluster number 2. So you can access to the data, okay? So if I verify that, I can execute my cluster number 2, and I'm going to execute psql. Psql is the command line to access to databases. And here I can create a table. Create table, guy-cd, ID integer, for example. Okay, I have created the table, and my table is here. Okay, and I have all the data inserted in my cluster. Okay, so this is a switchover. I'm going to proceed with the script number 9 that will do an upgrade. What is this script? If I cut the script, and if I show you the script, it's almost the same, but with some modifications. Here, I'm changing the version. Remember that in the previous script, I had the version 14.2, but I want to upgrade from 14.2 to 14.5, okay? Everything is similar, and here I'm configuring my backup strategy, my backup environment, okay? So my backup is in local, this IP is my local IP, to point to my Minio platform to store all the backups and all the walls of Postgres in my backup platform. I'm passing some credentials that I have created in the previous scripts, and I'm defining a retention policy of 1 day. I can define 30 days, 1 year, whatever. The only thing to do is to have enough space in your S3 platform, okay? So, okay, let me start the script number 9. Before to start, let me maximize this screen. Here we go. So what happened with this process? The cluster is in upgrading mode, so I'm moving from this version, 14.2 to 14.5. He's doing a rolling upgrade. He's starting with number 3, after the number 2, before to finish the number 1. So before to upgrade the primary server, it will switch from the primary to another primary, okay? So it takes a little bit of time. It depends on the connection of my connection. I'm connected to the Wi-Fi, and it's not very fast. In normal conditions, it takes 1 minute, all the process, even less. But now, it depends of the connection, it can take a little bit more of time, okay? So at the end, the final infrastructure that I will have is the 3 clusters, the 1 cluster with 3 instances, all the instances upgraded to the version that I have defined in my YAML file, and the backup will be configured. You can see here that the backup is already configured. By default, he will send all the walls to the object storage. If I verify the object storage here, if I refresh, again, it depends on my connection, which is not very good today, but it takes around 1 minute, okay? So everything that the operator will do is send all the walls to the object storage and do all of this stuff, okay? So I'm a little bit embarrassed because the connection is not good, and you can trust me, it works. Is the demo effect. Okay. Just let me show you some information about my cluster. Okay. Here we have 3 pods, 1, 2, and 3 with different IPs. We can have different services, as said. Let me show you. Services. Here you have all the services. 1 read-write, 1 read-only, 1 read, and 1 any that will serve all the others, all the instances that are created in the cluster. Okay, I think I have just 1 minute more, 2 minutes more. Okay. Just before to end, you can download this demo in this QR code. Everything is in GitHub. You can download the demo. If you like, please start the project. If you have any questions, you can contact me. We have a booth just downstairs, and you can come with me, and I can explain you more, and I can give you more details about how it works, the operator, if you are interested. Don't hesitate to download, to play with, and try in your environment and in your Kubernetes environment. More other capabilities of the operator. The operator can do a lot of things. One thing that is very important is that the data can be replicated between clusters. Okay, you can have a cluster on your premises, and you can have another cluster in the cloud, for example, and you can replicate the data from one cluster to other. So it's not in real time. It takes the time that it takes. It depends on your connection, but you can have a streaming to the other cluster. This is one feature that is very, very interesting for production environments. And that's all. If you have any question, don't hesitate to contact us. EDB is a software company. We support Postgres databases, open source and proprietary software. We are able to do Oracle migrations from Oracle to Postgres databases, a lot of features, a lot of tools for high availability, failover, backups and recovery, monitoring, trainings. So if you have a use case that you want to discuss with us, don't hesitate to come to the booth. Thank you very much, everybody. Thank you.
Thank you very much, Sergio. I had many reasons not to run SQL on Kubernetes. Now I do have a reason to trust Postgres on Kubernetes. Does anyone have questions for Sergio before we close? No? Okay. Thanks, Sergio. You guys have 17 minutes of freedom. That is 10 minutes more than I get. So you can. We will start again here at 1:45. That's 15 minutes before 2 for those that are that lack the math. So thank you very much, and we speak again later. So good afternoon, everyone. Your best Italian host ever. It's again here. We have had all lunch. We all have our refreshments. I see no. Okay. We have now Robin from Sipman. It's Robin Sipman from ING, lead developer. It's I must say it's beautiful to have. This is our first consumer of Kubernetes coming on stage. It's we always see vendors getting their talks through as not product pitch. Is fantastic. You guys are doing a great job, but it's also nice to see consumers, to see what the troubles that they go through to enable Kubernetes within their organization. So Robin, would you like to join me?
Yes, thank you very much.
Give it up. Thank you. Good luck.
Thank you.
The floor is yours.
Hello. So the mic is working, that's good, and everybody has a full stomach, I hope. So that's nice. I'm going to talk about ING's container hosting journey. So like you already said, we have our own private cloud, and we're building container hosting there. And one of the services that we offer on that container hosting is what we call namespace as a service. And this talk is mainly about what does that infrastructure actually look like, and how did we build that journey. So first, a little bit. My name is Robin Siepman. I'm the lead developer in the ING Container Hosting Platform team. That's what that acronym stands for. And ING is a bank, but we write a lot of software. We are very apparent in Europe, but we are all over the world. And in fact, the Container Hosting Platform team, the team that I'm in, is also a team that has many nationalities in there. I think that's very cool. And today I'm going to talk about why do we actually do namespace as a service as opposed to maybe giving full clusters out in the private cloud. And then what does that stack actually look like in the private cloud structure. And then I'm going to zoom in on how we built the namespace as a service on top of OpenShift. So I already spoiled it. We run OpenShift instead of Kubernetes, on top of Kubernetes. I'm going to talk a little bit about the dependencies that we have to build this journey. And then I'm going to zoom in to some of the controllers that we have, some of the applications. So there's some Python code in there, there's some Golang code in there. So I hope you're excited for that. And of course, a demo. I recorded it though, so it's not a live one, but it's a demo nonetheless. So let's dive in. So we only offer namespace as a service. And the goal is, I'm just going to go through the full slide. It's a lot of text. But in ING, we have a full cluster, right? And we don't want to give full clusters to consumers, because then we give out a lot of nodes, a lot of resources, and they will not be utilized fully. But if we build a multi-tenant cluster, and we offer namespace as a service, then we are in full control of the compute, and we can give out the resources to namespaces of those exactly what they need, right? So if one namespace of one application requires 10 CPU cores and 10 gigs of memory, we give it to them, and another namespace requires, et cetera, et cetera. So we spread it out over the cluster, but we are in control of the compute. And that gives us a number of advantages, also in terms of compliance. The people that request a namespace, they don't have to worry about the underlying infrastructure, right? The cluster, it works. They don't have to know what compute nodes they are running on, if they are patched, stuff like that. They offer, or they take the namespace that we give them as a service, and they also get the compliancy on top of that. So they know that the platform they are running on, it has been penetration tested, it has all the risk controls in place, and so on. It does mean that these teams, we have a lot of them, we have hundreds of teams that run, that use the same Kubernetes cluster. They are in control of the stuff that they deploy in their namespace. So the compliancy aspect of the cluster, yes, that's in the container hosting team's control, but anything that you deploy on top of that, that's the application team needs to maintain that. We will zoom in on that later. If you want to know more about what it's like to run on the container hosting team, there will be a talk from Adnan tomorrow, and he will give you the journey. So what use cases do we actually support on our clusters? We have two main use cases. One of them is 12 factors. I'm wondering here, a show of hands, who here knows what a 12-factor application is? That's quite a lot. That's good. That's good. For those who don't know, 12 factors, the easiest way I would describe it is that you focus on your app being stateless, So that makes it very easy to scale, and if one of your applications gets killed, it doesn't matter, you just spin up a new pod. So it's all about portability, scalability, and so on. So it means on the Kubernetes cluster itself, there is no persistent volume claims. There's no persistency at all. If you need persistency as an application, you connect to an external database. So external as in, it's not inside the Kubernetes cluster, but still within your own cloud, right? So this is the main type of workload that we offer. For consumers or for data services providers, so these are teams that really know a lot about how to handle persistency, how to handle storage. For those workloads, we actually offer a storage, which is built on top of Portworx. Where for us, they are completely separate clusters. All right. So this namespace as a service offering, what I'm talking about, what does that actually mean? Like, why do you have to build so much stuff for it? You can just do OC ADM new project and you're done, right? Well, not really. Because in the fact that if you do OCM new project, then how do you know which users have access to that certain project? You need to give people access to it, right? A group maybe. You're also going to need some networking in there. So maybe this namespace needs its own IP address. Maybe you need your own private network, and so on. In ING, we have Azure DevOps, where we deploy our code to on-premise. But there also needs to be a connection between that on-premise cluster and Azure DevOps. So how is that then created? And furthermore, we have multiple data centers in ING. So if one data center goes down, we can move to the other one. But it also means that if you request a namespace in one data center, it needs to be available in the other. So those are actually a lot of steps that OC ADM new project doesn't do. Yeah, and we have automated that, and that's mostly what this presentation is about. To do all of that, we have a lot of components. I've listed them here. One of them is the IHHV API that knows all about the different clusters in different data centers, how to orchestrate it. Then we have project controller that ensures that namespaces are on the cluster. And yeah, there's more. There's auth delegator, CDAS controller, image reporter, pod resource mutator, and quota autoscaler. There's a huge list of them. We have about 36 at the moment. Obviously, I can't handle all 36 of them right here, but I will zoom in on 3 of them. So I'm going to talk about the IHHV API, project controller, and the autoscaler there in this presentation. But before I do that, I want to show you what does our infrastructure actually look like. So for ING, we have a data center, we have multiple data centers, and then we have a team that offers bare metal as a service. So they make sure that the physical compute nodes that come in, they are registered and ready to be consumed by platforms. And then on one side, we have Azure DevOps, well, I should say ING One pipeline, which happens to run in Azure DevOps. And then we have a lot of APIs that we depend upon. So we have seen the B, that's for asset registration. We have a charging endpoint. There is some monitoring and logging in there, security monitoring, and networking. So these are all APIs that are offered in the ING private cloud. Now that we have our infra code, so everything for us is infra as code, and then we provision nodes via that using an IPI installation, running OpenShift 4.10, by the way. And then we get our OpenShift container platform. So this is just, this is an OpenShift installation without any of our own components on top of it yet. Then we have all the applications that you just saw. They're also in infra as code via GitOps. We deploy them via Argo CD on the cluster. And then we truly have the ING container hosting platform. And you can also see that these components, they connect to the APIs that are there, right? The internal infra APIs. And then finally, we can offer the namespace as a service on top of that. So we have a cloud portal inside ING, very similar to what the public clouds have, where you can click like, hey, I want a new namespace, and you go through it, and then actually you call our APIs, and then the consumer has their namespace. And of course, the consumers, once they have their namespace, they want to deploy their application. So they have their consumer code also in the one pipeline, and that goes into the namespace. Any questions about this slide? Because then otherwise I have to go back. No, that's excellent. So let me zoom in on some of the applications that we have. The first one I'm going to handle is called Project Controller. Project Controller is written in Python, and it's for namespace configuration management. When we originally started building this component, we were very well versed in Python in the team, but there was no Python operator framework for Kubernetes. So we built our own, which we call scaffolds. And I will zoom in on that. And what the project controller actually does is it takes a specification of a project inside ING. So for example, hey, I want a new project with this name, and I need these resources, it's bound to this group. And then the project controller, it creates all the resources associated with it. It creates the namespace, it creates resource quotas, it creates role bindings, and so on. But let me zoom in on the scaffolds framework first. So the way the scaffolds framework works is you have your own application. So this is if you're building Python code, right? You have your own application, and then you import this stream watch. The stream watch is offered by the scaffolds package, which listens to a Kubernetes object. So this can be a custom resource that you have defined yourself, or maybe it's config maps or whatever you please, right? And then via a watch, the stream watch listens to that, and then it calls event listeners. So event listener is also a class that the scaffolds framework offers. And that's what you inherit from. So you have a bunch of classes inherit from event listener. So this might seem a bit abstract, but if I zoom in like this, you can see that you implement a bunch of event listeners. So for example, in terms of project controller, an event can be like, hey, I want to create a new namespace. So you have an event listener for a namespace, you have an event listener for a resource quota. And then when a new specification comes in, so a new custom resource comes in, so let's say somebody tries to create an IHP project, then it goes to the first event listener that says, all right, I need to create a namespace. If that's successful, it moves on to the next one. It needs to create a resource quota. All right, cool. Then it moves to the next one, creates, I don't know, role bindings, and so on. And the cool thing is that all these event listeners, they are called in order. But if one of them fails, so let's say one of them fails, then the ones that have already been called, they will be rolled back. That's what you see there with the rollback. Cool. Another component we have is called the IHP API. So the component you just saw, the project controller, it's very cluster specific. It only knows about clusters, but the IHP API, it knows about different clusters. And that's what you see here. So we have a user, it goes to the workflow, it clicks, hey, I want a new namespace. Then you hit the IHP API, and it calls all those infrastructure APIs that I mentioned before. And then it calls the cluster API on every cluster, which generates that IHP project spec, and then it's picked up by the project controller, and then we have all these resources there. Well, that's a lot of orchestration, a lot of things that need to happen, and all of it is, of course, time-consuming. First, let me take a look. So this is what the API spec actually looks like. So these are the things that we offer. You can get some information about your namespace. You can create one, update it, and delete it. And you can also patch it. For example, if you only want to update your resource specifications, then you can do that. But in order to go through all these steps, or in order to get the proper namespace, these are the steps that we need to do. So a request comes in, and we first need to get some network information. And that network information needs to be registered in the CMDB. So that's the asset registration part. And then lastly, if that is all complete, then we need to charge for it, and we actually need to create the namespace on the cluster. Now, all of these stages, they happen sequentially. So only after stage 1 is completed, we move on to stage 2, and so on. But all of the units in a stage, so these blocks on the left and right are called units, they are concurrent. So registering stuff in the CMDB, it takes a second or so, right? But we do it all at the same time. Same for that, to speed up the process. But it does mean that if we are in the first stage, we don't want to wait all the way up until stage 3 to find out that, hey, maybe there is a naming conflict, right? So at the first stage, we already do a check stage, we call it. So we do some sanity checks if the request is likely to succeed. And only when the request is likely to succeed, then we continue with the run stage, and then we do some actual networking and so on. So yeah, if the flow is all good, but at the last time, you know, like at the last unit something fails, then we are in a little bit of trouble because we have executed a lot of actions, right? We have done the asset registration already and the networking is done, but somehow we cannot create this namespace on the cluster. In that case, we need to roll back everything that we have done so far. Now, what does that actually look like in code? So all the steps that you saw in the diagram, it is in code. So we have the first curly bracket that is a stage block, so to speak. And you can see the network creation step there. And then we have the other steps that seem to be create, the charging, and the namespace, but they are dry runs in the first stage. And then we have all the other steps, right? I hope this is clean to see. And then finally, we execute everything in the run stage cluster actions and reply call. All right. And the last component I want to show you is called quota autoscaler. So we found that on our clusters, or when you request a namespace, the requester of the namespace has to fill in how many resources is your application going to consume. And at the moment where you request a name, it's very hard to estimate, right? Some people haven't even started writing their application yet, and we are already asking them to give an estimate on how much they are going to use. So that's very tricky. And on top of that, then you start building your application, right? And you also need to fill in these pod resource requests. So how many CPUs is your pod going to use? And then again, you're going to make an estimate. And maybe after you've seen it running for a while, then you know what your application actually uses, right? You do your performance test, then you really know what it does. But it turns out that knowing all your resources before you request your namespace, that's really tricky. And to help with that, we have a component called the quota autoscaler. So what we do is we look at the namespace resource quota. So a resource quota is basically, I hope everybody knows what a resource quota is because we're all Kubernetes. But in case you don't, a resource quota is basically a limitation of the compute resources that your namespace can consume. So the sum of all the pod resources in your namespace, they cannot exceed what it says in your resource quota. Okay, so this is also what you pay for, by the way. Yeah? In the ING private cloud, everybody pays for their resource quota. Now, if we notice that that resource quota is getting full, we can watch that using this IHHP quota scaler component. And when it's almost full, we can automatically do calls to our charging endpoint. So to the IHHP API, we say, hey, this quota is almost full. This team needs more resources. Then we call our automation, and which increases the resource quota. This behavior is managed by a custom resource called a quota scaler object, which looks something like this. I hope it looks really familiar because it's almost the same as a horizontal pod autoscaler. So you have some behavior, and you can also set some minimum values and some maximum values. And you have to read the behavior like what would you like the CPU ratio to be? So if you set down the values 50 and 70, it would mean that I want my resource quota to be between 50 and 70% utilized. If you put down 100%, it means you want a 100% efficient usage of your resource quota. That means that there is no space for pods essentially to come up. You're fully using your resource quota. I want to share some metrics with you with how that affects the resource allocation on a cluster. So not too long ago, we were running on OpenShift 3.11, and this was what the CPU allocation looked like. So we have over 9,000 cores allocated in resource quotas. These are the actual requests. So this is what the resource quota look like, what the namespaces have, what you pay for. And then the request is the sum of all the pods, like what do the pods actually request. And you can see that teams highly overestimate how much resources their application actually need. And you can see the usage there as well. So you can see that the memory usage in terms of request is quite good. And for CPU, there is a lot more burst to it. And now we built another cluster, an OpenShift 4 cluster. And there we implemented the quota scaler. And you can see the difference, right? So we went from 9,000 cores to, give or take, 2,000 or 1,700 cores, and also for memory. So users no longer have to worry about what they fill in for their namespace resource quota. It scales automatically. And one other thing we did is that for dev and test workloads, we saw that there were a lot of high CPU requests on a pod level. And this also allocates the resources on the cluster. But for dev and test namespaces, they can be a bit more flexible, right? So for dev and test, we automatically scale down the CPU to 10 millicores, but we still allow users to set their limits as high as you can. So for those who don't know, if you request resources in a pod, you have resources request. Requests are resources that you are guaranteed to have, whereas limits, they are reached only if the resources are available on the cluster. And since we have so many compute nodes on the cluster, with us you're almost bound to hit your limits anyway. So this allows us to gain in this margin here. So we have the request for V1, and then for dev and test, we force it lower, and that gives us a nice bump there. Obviously, for memory, we can't do that, because we can't, memory is not as compressible as CPU. So here are some other metrics. So here you can see the quota scaling, and there you see the pod resource mutator that I was talking about. By implementing the quota scaler feature, we save 7.6 thousand CPU cores in namespace resource quotas, and with the mutation there for the dev and test namespaces, we save 500 CPU cores in the requests. So I already mentioned this, right? So the pod resource mutator for development and test namespaces only forces the pod CPU request to be 10 millicores, but the CPU limits can be kept as it is. All right. Last but not least, I have a demo. It will be a very quick demo. It is a video, but it shows the full stack as I've just told you in the story. So we're going to requisition a namespace via the IHHP API. After the namespace has been requisitioned, we're going to scale up some workload in it, and then we're going to see the quota autoscaler in action. All right, here we go. So there we go. Here is a namespace specification for the IHHP area. So it has a name, we have some workload type, we have some resource that we wanted to have. Then we post this payload to our automation, right? We create a namespace. So this creates the namespaces on multiple clusters. We can also see what operations it did. So we can see that there was some networking in there was some asset registration, and finally it was created on the cluster. Those are all the steps. Now, if we actually look at what is on the cluster, so the automation on the cluster, it creates its IHHP project spec. Again, it has the same name, it has the same quotas, it has the same workload type, and there's the name. And this is then picked up by the project controller, and that creates, in turn, creates the namespace, it creates the resource quota, so you can see that whatever in the specification is reflected in the resource quota there. It also creates role bindings, so what groups have access to this namespace, and you automatically get a quota scaler. Now, we have our namespace, let's deploy something in it. So I have this Nginx pod here, it has some CPU requests, it has some CPU limits, so let's make it happen. It's starting up. And we can see we are using some of our quota, right? We're using 250 megabytes out of 1 gigabyte, and our quota, we're using 1 out of 4 CPU limit. So we can scale up to 4 replicas before we hit our resource quota. So we are completely full right now. If you try to create another pod, it will fail because your resource quota is full. So we have 4 pods running. And now we scale it up to 6. We get all these scary error messages because, well, it's forbidden, right? You're trying to break out of your quota. But this is where the quota autoscaler comes in. It's actually listening to these events, and it knows that you are trying to scale up outside your quota. And it sees here, it calculates based on the specifications of the replica set, how much resources actually you need more, and then it calls our automation, and it updates the resource quota. And we can see it's actually updated there. And all the pods are running. So that's what you mean, what I meant with the 100% efficient resource quota usage. Yeah. There's more. I have one more slide. So I showed you a lot of stuff. I showed you some Python code. I showed you some other stuff. I mean, it's really nice to boast about it, but it's not very useful for you unless you can touch it yourself. So can you have all this code? And the answer is yes. Yes, you can. So at KubeCon, we will open source this live. Yes, very cool. And what will you actually get? So you will get the code for the quota autoscaler, the full component of the quota autoscaler, you will get it. For the operator, the Python operator framework, we will also open source it. You will not get a project controller yet. We are also planning on open sourcing that maybe. But for now, you will get the Python operator framework. And for the orchestration, you saw we had all these lines where we have like these stages that we run sequentially and the units all concurrent. That's what we call orchestration, and that will also be open source. So yeah, that is it. So now you can. Are there any questions? There are questions, but you guys don't have microphones, so that's.
Hi, hello. Thank you for your talk. I want to ask, do you use this in production? Because I've seen data from non-production, and I wonder if you already use that.
Yeah, we use everything in production, what you see here. But the components, they are all replicated across different clusters. So for DTA, there is an instance of the ICHP API quota autoscaler running. And for production, we have another instance running across multiple clusters as well. So yes, everything you see is running in prod.
Okay. I wonder why the choice of giving the data for non-production instead of production, because it will be more impressive maybe to see how much resources you save in production.
Yeah, the reasoning for this graph is that we noticed for dev and test, a lot of resources are allocated. And for production workloads, we are not very eager to scale down the request. Like if a team says, hey, they need that many resources to run in production, we believe them. We're not going to touch that. But for dev and test, we can be a bit more aggressive. And yeah, that's why those metrics are a bit more interesting. But for the production metrics, they are perhaps a bit less because you don't have the pod resource mutator, but for the quota autoscaling level, it's still very beneficial.
Okay, thank you.
Yeah, you're welcome.
Hi. I'm working at Alliander, and we have a similar workload. And I wonder, well, we made some different decisions, and we actually used some market solutions like Capsule for creating namespaces automatically by the developers themselves. Also the vertical pod autoscaler, but the last one, yeah, it's not working properly for us. So maybe this is convenient to use, but I'm wondering why why is ING developing these solutions themselves? Because there are some solutions in the market.
Yeah, so for the namespace as a service part, we have a lot of interfaces inside ING that are very ING specific. Like for example, our networking implementation, it is just very ING specific, so we cannot ask a vendor to build that for us. And for the second part of the scaling part, so it actually works with the horizontal pod autoscaler as well as vertical pod autoscaler. You can use both of it. And this quota autoscaler kind of runs on top of that. So you can see it as like a management for your namespace resource quotas instead. And we talked actually with multiple vendors and multiple companies. And none of them had built it yet. So therefore we did it. And you can also use it because when it's open source. So I hope that answers your question. Okay, thank you. Yeah.
One question, because I saw that there is a CMDB record against the namespace. So can, with this orchestration, can you get multiple namespace per CMDB record, or it's one namespace per CMDB record?
Yeah, so what we do is, because we run many clusters, and all these clusters, they can have the same namespace, right? So depending on how many times you want it replicated. And what we register in the CMDB is we combine the namespace name with an identifier of the cluster that you have. So let's say your namespace is example, right? And then we will have example 1, 2, 3, depending on like 1, 2, 3 being the cluster identifiers. Does that make sense? Yes. Yeah.
Hi, thanks for the talk. do you have any restrictions on the upper limit for that quota autoscaler in case of misuse or security incidents?
Yes, yes, we do, and I'm sad to say it's also necessary. Yeah, there is a limit. We have, from the top of my head, I think we have like 35 CPU cores and like 150 gigs of RAM per namespace. It can be that some of the workloads that we have, they actually have an extremely high load, and then they use all these resources, and perhaps they need more. And usually these are big consumers. We talk to them about their use case, because if a team hits these limits without talking to us, then usually they are overcommitting the resources that, like, they are requesting more resources than they actually need. So this limit is in place, and then we talk about it on a team-to-team basis if they need more.
We have a question in the back of the room, Robin?
Oh, yes.
Hey, you did explain about the support for 12-factor applications. I was just curious, does ICHP support stateful applications as well, or?
Yeah, so we currently only provide stateful applications for data services. So for most of our consumers, it's all stateless, 12-factor. But for inside ING, we have providers that offer data service. For example, the ELK stack. You might know the ELK stack. So
yeah,
these guys.
I worked in ING for 5 years, so I don't know.
Okay. So the ELK stack is a consumer of persistent storage. Yeah. It uses the same automation in the end.
Robin, are you okay to take one last question?
Yeah, of course.
Thank you. I have a small question. Since you're basically the private cloud service provider, how many clients do you have at this moment, more or less?
So inside the cluster, we have a little over 2,000 namespaces. And I think together with non-prod and prod, we run about, I think it's roughly 5,000 pods. And that's per environment, right? So we replicate everything in another data center as well. Were these the metrics you're looking for? Or?
Because I was curious actually about the more technical part of this, which is the persistence of the Kubernetes clusters that you're using under the hood. Basically, did you go with the custom solution regarding the storing of the state, or are you still using the standard one, which is etcd?
Yeah, we're still using etcd, yes. But for the, so are you referring to the storage we use for our own APIs, or the storage we offer for our data services consumers?
No, the internal one specifically for the need of the Kubernetes clusters.
Yeah,
so
it's etcd. Yeah.
It's still enough. Okay, thank you.
Yeah, we found etcd, I think it's performant, but it's keep a good eye on the metrics, and you may also need to fine-tune it, right? There are quite some nice articles about it, where you can say, okay, I have a huge cluster, what metrics do I need to fiddle with, or what parameters? Yeah. All right. If you have more questions, I'll be walking around still. So thank you very much for listening, and have a great day.
Well, thank you very much, Robin. I am 100% sure that people will come find you, not necessarily for good things. We have, now, we're going to restart at 2:30 with Ara, and she's going to show us about the Gateway API. So you can stick around, you can go get some refreshment, but please be on time. We're going to start at 2:30 sharp. Thank you. All right, all right, all right. So we are starting again with Ara Pulido, developer advocate from Datadog with the Kubernetes Gateway API. After Ara, we're going to have a 30 minutes break, and we're going to restart again at 3:30. But for now, Ara, will you join me? Give it up for Ara, please.
Thanks, William.
Good luck.
Thank you. So yes, I'm Ara Pulido. Thanks for having me, and thanks for the organizers for this amazing conference. It's super well run. The venue, it's super cool. It's like a club. Come on, this is very hacker club 90s kind of feeling, which is great. But today I'm going to be talking about Kubernetes Gateway API, which I consider it to be the new way to travel north-south. So just some words about Datadog. It's a platform that helps companies improve observability and security of their infra and applications. And that, of course, includes Kubernetes as a platform, but also the workloads, the applications that you run on top. We actually have a brand new office in Amsterdam. They're very keen to host community events. So if you have a meetup that you want to have a space to run, just ping me, and I'll put you in contact with the right people. But today, north-south traffic. What is north-south traffic? And I wanted to call this talk north-south, and also to explain a little bit this term, which not everybody knows, and I didn't know. And when the first time that I saw north-south traffic, I was so confused about it. What is north-south traffic? It's just external traffic into your cluster. I don't know why we come up with terms like that, but that's basically north-south, as opposed to west-east traffic, which basically means the traffic in between the services into your cluster. So this is more or less how it looks like north-south. But because of the slice format, most of my graphs are going to look like this, but always north-south. Good. So how do we do north-south traffic in Kubernetes? So usually what we do, we have to get a load balancer to get traffic in. And if you're in a public cloud, so if you're running GKE or AKS, and others, all these clouds provide controllers. So when you create a service, and Salman explained a little bit this morning all about this, so thanks to that I can be a little bit faster on this. If you do a type load balancer service, the cloud internally is going to have a controller that is going to provision an actual load balancer for you. And that's how you get traffic in your cluster if you're in a public cloud. If you're running your own infrastructure, you can actually write your own controller to do the same thing. But what happens in reality is that you may have more than one service that you need to get traffic from external. And having a single load balancer per service is not a great idea because they are very expensive, because they are scarce. They actually give you an IP that is routable on the internet, and we know that there are not that many of those. So they get pretty expensive. So what we do in Kubernetes up until now is that we create these ingress objects. And basically an ingress object, it's an abstraction of things like reverse proxies, for example, L7 reverse proxies. So you are able to route traffic based on HTTP application level. So you can say things like, if the traffic is coming to corporate.com, route the traffic to my service called corporate, but it says shop.corporate.com, route the traffic to service e-commerce. And that's usually what we do. And this is how the ingress object looks like. It's basically that. There are a couple of more things you can do, things like TLS termination and put it there. But it's very, very simple. It's a very simple spec. It's part of the networking core Kubernetes API, so very official. It's GA. But it's super simple. It's like basically you create rules based on, for example, the host. And you can do reroutes based, for example, on URL prefixes. Again, you can do a little bit more than that with ingress, but that's more or less what you can do. In this example, If the traffic goes to foo.com/foo, it routes the traffic to service 1 on port 4200. If it does /bar, it goes to service to port 80. And that's very simple to understand. It's a very, very good abstraction, to be honest. So we're good, yeah? We're right. We can finish this talk today. Not quite. If we step back a little bit, we know that in Kubernetes there is this reconciliation loop. We have a set of binaries called controllers that basically what they do is watching for changes on your cluster for specific resources and do something about it. And there is a component in Kubernetes called the controller manager that has a set of controllers. You have controllers for replica sets, for deployments, for other things. And those come from Kubernetes itself, so from the Kubernetes distribution itself. The ingress object is not like this. The ingress is a core Kubernetes API, but it doesn't come with a default controller. You have to deploy it on your cluster externally. So you only get the API, but not the controller with it. So what happens is that many options. I just put here 4 of them, but basically any open source project or company that they are on the realm of, I don't know, API gateways or reverse proxies, or all that area, probably are going to implement one of these ingress controllers. And this should be fine. Like the API, its core is there, so you should be able to move from one to another, and everything should be fine. The problem is that the ingress resource is pretty simple. And you may want to do things, very classic things that you do with reverse proxies, like shifting the traffic based on weight. Like if you want to do canaries or A/B testing or things like that, you may want to say, okay, send 90% of the traffic to the first version of my application and 10% of the traffic to the second version. But the ingress object doesn't allow for this. But because it feels like it should, all these implementations started to actually accepting to do these things in several ways. Again, the ingress object only allows for many, like very small number of things. But here comes Nginx and says, okay, my users wants to do canaries. So if you want to do canaries using the ingress object, you're able to hack it a little bit with annotations. So we are going to provide you with annotations that our ingress controller understands, and you're able to do these things that you want to do. That's great, but then comes Contour and said, okay, if with our ingress controller, you're able to do anything that you want to do with ingress, but if you want to do something more, you're going to use these CRDs that we came up with instead. Same with Ambassador, they came up with different CRDs, and Con with a plugin that is not even part of the open source release. So you can start seeing the problem already. And this is not only happens at a L7 reverse proxy level. This is where the problem is really, really apparent, but it also happens at an L4. So because the spec of service in Kubernetes only allows to say type load balancer and nothing else, cloud providers also do these things because they say, okay, I can provision for you a load balancer, but I actually have 3 types of load balancers. Which one do you want? So because you cannot say that, you, for example, in this case, is an example with Gkey, you can create an annotation to get, for example, an internal load balancer. So we have a problem in Kubernetes, and this is why they came up with Gateway API. So Gateway API to the rescue about 3 years ago, so it took a while until this was more or less usable. A lot of people in the networking space in Kubernetes, coming from Google, coming from Contour, with all the same people who created the problem, acknowledged that they had created a problem, and they started trying to fix it. So they decided that they wanted to build a set of new Kubernetes APIs to deploy L4 and L7 routing, so both levels, not only L7. And from the very beginning, they had this North Star to focus on while designing it. And this North Star was like, the Gateway API is going to be designed to be portable, meaning that if you have a resource that you have created in a controller, you can move to a different controller, and it's going to continue. It's very simple, but it's clear that we need a little bit more. So we are going to build it so you can express all your routing needs. But it's also going to be extensible, because we know that at some point we cannot design everything for now and the future. So we need to design it in a way that it can be extended in the future. And also role-oriented, with the idea that because we are going to create so many different resources, each of those resources are going to be designed for a specific persona in your cluster. So not all your users, the users of your cluster are going to be using the same type of resources. Good. So without further ado, this is the most important resources that you're going to find on the Gateway API. Not the only ones, but basically it's very simple. Gateway classes, gateways, and routes. And there are many types of routes. Again, this is L4 and L7, so we have TCP routes, UDP routes, gRPC routes. But the most mature, obviously, and really the first one that was designed is the one that we are going to be seeing today in the talk, which is HTTP routes, which you can consider really the replacement for the ingress object. So how does it look like? The gateway class, and thinking about this role-oriented model, is going to be created by infra providers and nobody else. So if, for example, in this case, if you're running, in this example, if you're running a key cluster with Gateway API, which already you can do, they are going to have these gateway classes for you. So instead of having to create an annotation for the type of load balancer that you need, they are going to have those created for you. You can see there is a typo, external. This is actually on GKey, so if you create a GKey cluster, you can see that there is a typo on their definition of gateway class, at least last time I checked, which I found it very funny. But then once you have those gateway classes that you can use as a cluster operator or as an application developer, if your policy allows for that, again, this is the different resources allows for a very specific RBAC rules to control who can do what. You're able to create those load balancers by creating gateways on your cluster. And you have to specify basically a gateway class. If you do this in GKey, again, I mentioned GKey a lot because they have a very, very mature implementation, not like other clouds at this point. But today we are going to do a lot of examples on HTTP routes, which I think are the most important ones for most people, and most people are application developers. I didn't have time to do demos. I only have one demo for today, and it's recorded. I have actually 3 examples. I'm going to show 2, one of them with one demo. I didn't have time while I was rehearsing this talk. I was already over the time, so I decided to reduce a lot. But you can run everything, all the examples on a kind cluster. If you clone that repo, you have all the examples. So you don't need anything else. On those examples, I'm using Contour as the controller. And the reason why I use Contour is because it's open source. And also, they have a very, very up-to-date implementation as well. We are going to be using an application, so this is the app for the example. So it has a front end and a couple of services behind, discounts and ads, backed up by a database. This is how it looks like if you run the demo. You can see it. So this is just an e-commerce example application. On the left, you see what the discount service is going to bring back, which is a discount. And on the right-hand side, you can see the ads that you get. And the reason why it's just says 1 point something is to distinguish two versions, because we are going to do routing of traffic. So you will see that you can get version 1 in blue or version 2 in red, and that way you're going to be able visually how the traffic is being rerouted. And everything, by the way, it's if you clone the repo, all this application is already instrumented with OpenTelemetry. So if you use an OpenTelemetry backend, you can actually see how the traffic is actually being routed without having to do all the tests. So you can use its own OpenTelemetry. You can use it with whatever backend. OK, so let's see a couple of examples. The first one is something very simple that you usually do with Ingress. Is like you say with a particular host, if the URL is /foo, go here, /var, go there. This already you can do with Ingress, so there's nothing special here. But the problem is that if you do that with some frameworks, some web frameworks like Rails, for example, they will get confused because they expect the application to be on the root URL. So what you do usually on reverse proxy is rewriting that URL. And that's something that all these implementations can do, but the Ingress object doesn't have an abstraction for that. And you want to do that, rewriting that URL, so your application believes that it's running on the root. So you can do this with the gateway API specification. So the first thing we need is a gateway and a listener, in this case HTTP. And one of the things that, from a security model point of view in gateway API, is that because gateways may be created by operators in a different namespace, they need to say, OK, I'm going to allow this gateway to be used by routes that are being created on specific namespaces. Obviously, you can allow all your cluster if you want, but you can specify only certain namespaces. In this case, the ones that match this label can use the gateway. Then you need a couple of HTTP routes. This is how it looks like. This is very similar to Ingress, as I said. You can do path prefix. So anything /foo goes to front-end on namespace 1. Anything /var to front-end on namespace 2. But this is the interesting bit. The interesting bit is that interesting things like URL rewrites now are part of the spec, meaning that you write it the same way no matter the controller that you're using. So once we do that, you can see that if you go to /foo, it goes to version 1, /var goes to version 2, and the application continues working. And the reason why it continues working, if we check the trace that is being created, you can see that the application thinks that that is coming from the root URL. OK, so another example, and we are going to see a recorded demo for this one. You can see in this case the example that we started with, something that we want to do, and Ingress didn't allow us to do it, but the implementations did, which is routing traffic by weight. So in this case, we want to route traffic 80% of the traffic to our first version and 20% of the traffic to the second version. And in this case, they have a new object called the reference grant, because I'm saying that a route is going to cross boundaries to the next namespace. In order to do that, you can do that with Nginx and Ingress already without any permission. So unless you have network policies or things like that, it allows you to do that. In this case, they thought, OK, if you want to do that using the Gateway API, as the owner of namespace 2, you are going to accept traffic coming from routes. So the way we are going to do that is, first, we create the HTTP route that has two backends, one in namespace 1, one in namespace 2. And you can see that routing traffic by weight, it's in the spec. So it's part of the spec, something, it's not an annotation, it's not another object that we don't know where it's coming from. It's actually part of the spec. So something that you can do in the spec. And then we have the reference grant. So on namespace 2, we are going to create a reference grant that basically says, I'm going to accept routes coming from namespace 1 to send traffic to my backend services. Okay, so let's see the demo. Let's play this. So basically, this is the same thing that we saw. So we are creating first the reference grant, and we are going to also create the routes. In this case, the route. And once we do that, if we start refreshing the page, we are going to get 80% of the times version 1 and 20% of the time version 2. So I fast forward this a lot of times, and after a while, I can use these OpenTelemetry traces to think about whether the gateway API and the controller are doing what I'm supposed to be doing. So if we check the traces for the ad service, we can see visually in purple is version 1.0, in blue is 2.0. You can see visually more or less 80% of the traffic is going to the first version and 20% of the traffic is going to the second version. And you can also see some latency issues on the second version that probably you need to check out. Okay, cool. So that was an example of what you can do, but I wanted to talk about as well on a little bit of some of the design decisions on the Gateway API that I found them very, very cool. So we mentioned at the beginning that it's designed to be portable, so you can move things from controller to controller and they continue working as expected. How do they do that? I, as an implementator of one of these controllers, how do I make sure that it's going to be portable? So basically, they offer support levels for features. The Gateway API have a set of core features, and those core features mean that if you want to be compliant, you have, because they have a set of compliance tests, you have to implement everything on the core level following the spec. So if you don't want to be compliant, that's fine, but if you want to, that's how you do it. Then there are a set of extended features, meaning that it's optional for you as an implementation to implement this set of features, but if you do, you have to do so by following the spec. You cannot create annotations or tricks. You have to follow the spec. But they understand as well that they might be things that are very implementation specific because these things are very broad. Some not, for example, in the case of gateway classes, not all clouds are going to have the same set of resources. So there are things that you can implement that are specific to your implementation, but you have to do so following also some rules. And the other funny thing about the design of the Gateway API is that they have a different release model. So we are used to APIs in Kubernetes to be part of the release of Kubernetes. In this case, they decided early on that they were going to be released as CRDs. That doesn't mean that it's not an official API. It's an official API. It's gateway networking, kates.io. But they decided early on that because there is not going to be a default controller part of Kubernetes, it's going to be always external. There is not that need of type that with specific Kubernetes release. And also, CRDs are so mature now that people know how to deploy them, how to maintain them. So they decided that this was going to be the way to release the Gateway API. But because they're official, they have to have some rules. And this is the way they manage those releases. So first of all, you have API versions. In this case, we have V1, Beta 1. Some resources are already beta. Some resources are still V1, Alpha 2. We only saw 3 of them. There are many of those. Once nothing is GA yet, but it's going to be probably pretty soon, at least for 3 of them. But inside those resources, they also have standard features and experimental features. And standard features meaning that they are mature enough that they believe that they are not going to change that much. Obviously, it's a beta object, so it still can change a little bit, but they're pretty confident that they got it right. But then they have experimental features. Things are, you have to know that they are going to be changing. And anything in alpha everything is experimental. So they get all of that, and they release versions of the Gateway API. The latest one is 0.06, actually 1, but more or less 0.6. The only thing it changes a little bit of compliance tests. And they basically release a version based on what they have. But then you have, as a consumer of the Gateway API, you have 2 ways of getting, 2 channels to get that, because it's not part of Kubernetes release. So you get it through these channels, depending on what you need and the level of maturity that you require for your clusters. So if you get 0.60 from the standard channel, you're only going to get V1 Beta 1 resources and only standard features of those resources. And actually, on the demo, if you clone that repo, in the demo, we are using experimental feature. URL rewrite is an experimental feature, part of HTTP route, which is a V1 Beta 1. So what I did is to download 0.60 from the experimental channel, in which you get everything. You get V1 Beta 1 resources, also Alpha 2 resources, but you get experimental features as well. OK, so coming to the end. So just a recap, Gateway API is a new Kubernetes API extension to standardize vendor implementations for both L4 and L7. It's an official Kubernetes API, but it's based on CRD, and this may confuse people at the beginning, but I believe that it's going to become a pattern. So they are the first ones, but I believe more APIs will be written this way. And if you use it, watch out for 2 things: support levels, if you're choosing an implementation, and also the maturity level. So what type of experimentation you allow in your cluster. And that's it. Thank you very much. Datadog is hiring, so if you see anything on our careers page that looks interesting, let us know. And that's the repo in case you missed it. Thanks.
So thank you very much, Ara. That was brilliant. Do we have any questions for Ara? Yes, we do.
Two questions, actually. The first one is there a way to define the custom traffic split, like based not on the weight, but on the request itself, like headers?
Yes.
And maybe some external decision logic.
Yes, or everything that you can think, at least the things that we're already allowed to do with ingress on the Hacky way, all of that, obviously they had that as the base to define. So yes, headers is definitely one of.
Okay. And the second question, is there like version compatibility metrics between Gateway API versions and Kubernetes cluster versions?
Again, it's a CRD, so it's if you can use whatever version you're in. Okay. You have I think it's more important that to think about whether those implementations have any problem with one version or the other.
I noticed one thing regarding the CRDs that you mentioned. Basically, the first time I saw the API was that in order to include it into the cluster, you had to actually install these manifests to make the CRD accessible. And now you mentioned that there are actually no plans to introduce this into the standard Kubernetes API. Who is governing this gateway API then? Is this CNCF or?
It's the SIG. It's a very good question. This is part of SIG networking. So the same people who are managing the ingress, for example, API. So this is completely official part of SIG networking. And one of the reasons I think why it took a little bit longer is because they had to come up with a good set of conformance tests, a good set of release model, because they're a little bit pioneering on how to release this. But again, I really believe that there are going to be more SIGs creating new API extensions this way. Because again, if there is no controller that is based, that is part of Kubernetes, like Gateway API in this case, there's really no need to tie that to a release model, and it gives them a lot of flexibility. They can have a different pace of release if they need to.
So
one thing that is important is that once it becomes GA, and probably the first resources that are going to be GA are the same ones that are beta right now, which are gateway class, and HTTP routes. Reference grant, I think, is also beta at this point. Once it gets to GA, it's not changing. So that's why it's taking a while to get to that level, because they want to make sure that they are not going to say a month later, oh my God, now we are GA and we want to change it. So they won't change the resource.
Thank you very much, Ara. We are going to have a little break now until 3:30. At 3:30, we are going to have Christina Devotko. I don't know if I'm pronouncing it right. Pretty sure not. With managed services, with managed Kubernetes service. So you're free for half an hour. Thank you.